Hi everyone. I guess it was awesome session for yesterday. So now today we have the second session of this PLC. So I welcome you all again to the next and last session of the schedule which we have planned for. Although I already promised you that in future, if we get some feedbacks, if we get some time, we'll do few more sessions and also we'll try to have SCADA, HMI, Drive, and others as well, right? So for now, as we know that we discussed yesterday that we will be covering the advanced version of PLC. So today I have Micrologics 1400 with me, right? And after this, we have to also look forward for the Siemens one, right? So I guess you have recalled each and every concept which we discussed yesterday. I'll repeat the things like yesterday we completed around 3 hours of YouTube live stream, and after that around 40 minutes of Zoom meeting that was basically especially for doubts. And I hope I have cleared each and everyone's doubt. So now let's start with today's session where we have to cover Micrologics 1400 with RS Logics, RS Links actual softwares, and also looking forward for Logics Pro, right? So let me share my screen and then we will start the session. So I'm going to interface this RS Logics 1400. So the very first step, which I told you yesterday, is same for the day. Device manager, we have to go to check the COM ports because as now the PLC is changed, obviously the cable is changed, obviously the port is changed. So we need to verify the port number. So the port number is COM9. Okay. In this case also, I'm using RS232 standard serial communication and the cable is uh, RS232 PM02 DB9 male female USB connector, and this time it is connected with COM number 9, communication port number 9. So let's go to RS Links Classic and the same steps which we followed yesterday. So let's start it and communication, configure drivers. We see that already one driver is running here, so we can stop, delete, and create our own driver RS232, add new ABDF11. Let's change the COM port to COM9. And once we change it to COM9, simply auto configure, click OK, and close. We are done with it, right? Now, next part is we have to open the RS Logics software, right? Which is basically the programming software which we used yesterday also. Today also we are using it, right? We'll be doing it in two parts, uh, Allen Bedley and then Siemens, right? So first let's complete this one and then we'll switch to the Siemens. Siemens won't take much time because once you understood the concept of one PLC, it would be very easy for you to go jump to the another PLC, right? So let's create a new file. Yesterday we selected the Micrologics 1000 series, but today we are using 1400 series. So we need to choose that one. All the PLCs compatible with this software are already listed. Okay. So we can choose the PLC according to, we can choose the series according to our PLC hardware. So currently I have RS Logics 1400. So I'm selecting that one and creating a very simple program with a very first program. And then I'll switch to where we left yesterday. But for very first program, I'm doing it I colon 0.0/0, the first input, and then one output. O colon 0.0/0, right? Now let's download. Same process again. Save, replace, download, and yes. Okay, so now we have input I colon 0.0/0 and output O colon 0.0/0. Okay, so today we have PLC. I guess we need to check the output. I'm not going to PLC. If you want to check the output from the software also, you can simply right click and click toggle bit. Sorry, force on. If you force on, you can see the output is turned on here. I understand that this camera screen is very small. So let me do one thing for you. Now look at this. So now this output is completely on. Okay. And if I make it off, now how we can off it? Simply Let me share again. 1 second. Yeah. So if we have to turn off, let's remove the forces. So now the output is off. I'll do one thing. I'll tell you the number of inputs, number of outputs, each and everything. So let me describe you the hardware and then we'll come back to the software part. So in this PLC, we have almost 20 inputs and 12 outputs, right? In this PLC, we have almost 20 inputs and 12 outputs. So starting from here, right? This is okay, it is auto focusing. I need to adjust the setting of my video player. Just give me a setting. Give me a second. Yeah, yeah, now it's good. Okay. So we have 20 inputs, Micrologix 1400, SMPS, okay, and this one is the cable. Now we have 20 inputs starting from here, I colon 0.0 slash 0 slash 1 slash 2 slash 3, 4, 5, 6, 7, 8, and then 9. This one is the level sensor, level switch, okay. This way it come up, this way it go down. So if we put this one in the water tank or any other liquid tank, if it come up, it means the tank is full, and if it's go down, tank is empty, right? So let's start it again. I colon 0.0 slash 0 slash 1 slash 2 slash 3 slash 4 5 6 7 8 9 10 11 12, and then from here 13 14 15. 15 is the last bit, right? So now we need to change the word address. So the address would be I colon 0 dot 1 slash 0, 1 slash 1, 1 slash 2, and 1 slash 3. This one is proximity sensor, right? After this, we have 12 outputs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is fan, DC fan, right? And these are basically AC bulbs, which I have connected here. So for these bulbs, because we know that PLC will give 24-volt DC output and we cannot control the AC operated device. So what I have used a relay. So here I have used a relay to turn on these two bulbs, right? Now addressing O colon 0.0 slash 0 slash 1 slash 2 slash 3 slash 4 slash 5 6 7 8 9 10 and 11. 10 because only one relay for both. Okay, only one relay for both. Right now, let's come back to the yeah. I need to check the output I was showing you. So we have created the program I colon 0.0 slash 0 is on. The output is on. If I off it, the output is off. If I on it, on. If I off it, output is off. So this one is the toggle input. Okay. This one is NC and rest all are NOs. Okay. I told you yesterday, like the green color button is NO and the red color button is NC. But today the thing is changed because now we have red buttons, but all these are NOs. Although I told you red button for NC, but that have a condition. When we're talking about red button NO, they must be steel buttons. Steel buttons. These are plastic buttons. Okay, temporary buttons we can say. So that's why they don't have any standards for this. So it is not actually industrial button which I have used here. So it is NO. Okay, but the concept is again same which I told you yesterday. Red for NC and green for NO. Okay. Now let me share my screen and I'll do one thing. I'll put another input, that is the proximity sensor. Okay. So if we go back to the proximity sensor, it is I colon. It was the 20th input. Okay. So the address is I colon 0.1 slash 3. It will show you number here 19, 0 to 19, 20th. So address is I colon 0.1 slash 3. Okay. After this output, I'll be using this time. Which one? I'll be using that AC relay one. Okay. That is the 10th output. So O colon 0.0 slash 10. We need to write this. After this, let's go to download the code. The proximity sensor have different types. So this one is the metal sensor. It will detect the metal. Okay. So I need to put the metal around it and it will give us the output. I understand. And you may also see that on the back side, the bulb is on because this proximity sensor is working as a NC. This proximity sensor is working as a NC. and it is giving us the logic without even sensing, but it gives you opposite logic. Without sensing, the output is on, but when it is sensing, the output is off. When it is sensing, the output is off. So I'm using one metal to detect. If I place the metal, it is giving us zero logic. And when I remove the metal, it is giving us one logic because it is working in NC. Okay. So let me remove this because it will create a lot of problems during the live. So let's remove it. Okay. Now I have removed the lamp. Okay. That's why it's not on. Otherwise, the program is on, the output is on. Fine. Now we understood this. If we have to make, if we have to make this sensor work as NO only. Currently, it is by default NC, giving one logic when it is zero and giving zero logic when it is one. Now, if we want to take and if we want to use this sensor as a NC, what we can do, make this symbol opposite. NC input I have used here. If you're not able to understand what I did, I simply changed the instruction type for XIC to XIO. X mean examine, I mean if, O mean open, examine if open. Or otherwise, if you're not able to do it, delete this, put another NC, okay? Put I colon 0.0 slash I colon 0.0 or 0.1 slash 3, right? Now, this sensor is default NC. I'm using the symbol NC. So NC and NC will make NO. Okay, this is according to XOR gate. NC and NC will make NO. So now this sensor is not going to work as NC. It will work as NO. That means if it sense the metal, it will give you output. And if don't sense the metal, it won't give you the output, right? So let's check it. I'm going back to the hardware. Let me connect the bulb again. So now you can see, let me put a metal as well. Now we can see when we not keeping, let me stop sharing the screen. Yeah. So now when we put the metal, the output is on. And when I remove the metal, output is off. Again, when I put the metal, output is on. And when I remove the metal, the output is off. So now it is working absolutely fine. It is working as NO, right? So this is the change thing which we understood for today. Now, let's continue from the same thing which we left yesterday. Let's go offline. Okay. I guess now we understood about the hardware. So let's try to understand the things again according to simulator. Okay. So now I'll continue to that thing which we left yesterday, and that was let me keep it here. Let me turn on the simulations, and then let's make a combo of 3 timers. Okay, so let's pick one input and 3 timers. Quickly, I'm putting it. And after this, I'll start saving the code so that whenever we have to edit, it don't take much of our time. Here we need to place binary again. Here also binary. Let's pick timers in parallel. 3 timers we'll be using. So address is T4:0. Today base time is 0.1 according to simulator. If you need the delay of 3 seconds, let's make it 30. And then let's make it T4:0/DN. This DN we are using so that we can on this timer once it is off. Okay. Because we already know that done bit turns on when the delay is over. So after 3 seconds of first timer completion, this bit turns on and allows the current for this time. So then this timer will start. Now need to put T4:2. Next one. And again, 3 seconds of delay. And then T4:1/DN. So 3 timers are connected. Let's take 3 outputs. Okay. What we are going to have, we clarified that to you. We are going to make a simple program today. Okay. And what's that program? Let me write here. We will use 3 different outputs, O:, One second. Let me, yeah, now it is fine. So we will be using three different outputs, O colon 2 slash 0, O colon 2 slash 1, and O colon 2 slash 2. Let's say these three are valve 1, valve 2, and valve 3. Okay. So I want to start these two valves for first 5 seconds. Once these valves are closed, then this valve should be open. And after these two valves, we need to turn on these two valves. Yesterday, the scenario was we have to turn three motors one by one. M1, M2, M3. First motor on for 5 seconds. Next motor on for 5 seconds. Next motor on for 5 seconds. Now I have changed the combination, just change the name from motor to valve. But this time, first these two valves for first say 3 or 5 seconds. So let's take it according to our timer, 3 seconds. Then this single valve for next 3 seconds, and these two valve for next 3 seconds, right? So first we want valve 1 and valve 3, then we want valve 2, and then we want valve 1 and valve 2. So let's create the program for this, right? Come back to the screen. First of all, I'm taking three different valves. So O colon 2 slash 0 and O colon 2 slash 1 and O colon 2 slash 2. Three valves we have included, right? Now we have to turn these, even if you want to mention the names, edit symbol, write V1, write V2, and write V3. Okay. Now we have to turn on two valves, V1 and V3 at first. So can we see that whenever we will be, running the timers, we already know the first timer is T4 colon 0. The second timer is T4 colon 1, and the last timer is T4 colon 2. So can we do one thing, that let's take these two valves, these two outputs on with this timer, then this valve with this timer, and then this valve with these valves with this timer. Okay. So what I'm saying, we have to turn on this one and this one at first with T0. T4 colon 0, writing in a short. I hope you understand. Then we have to turn on this one with T1, right? Then we have to again turn this on with T2, and then this one also we have to run with T2. Let's not make it too complex. Okay, I'll make it as simple as possible for you. Okay, let's do it this way. Let's focus on this output. How many times this output, this valve is on? Two times, with 0 and with 2. So let's place two inputs in parallel to give current to this output, 0 and 2 TT bits. Why TT bits? Because we know TT bit will start and cut off automatically. So we need these two outputs when we have to run this timer only. And we need this output when we run this timer only. So it will turn off automatically. Got it? Okay, come back. Again, let's discuss it. So first of all, we have to do what? We have to turn on this output. Okay, we are not going according to the flow of timer for now. We are talking about the output scenario. Okay, so this output is on two times, 0 and 2, with the help of 0 and 2. So let's take 0 and 2 in parallel for this timer, this output, I mean, then talk about this output. So now this output is also turned on two times with T1 and T2. So let's turn on this output. Let's turn on this output with 1 and 2. Then the last output is turn on with only 0. So let's connect 0 here. I hope you understand what I did. Okay. So practically, I'll be doing it now. Okay. Let me delete each and everything and come back to this. So first output, we have to turn on with two inputs in parallel. Then this was also two times, two different inputs. And this one is also only one time with one input. Let me write the inputs also. It is T4 colon 0 slash TT. It is T4 colon 2 slash TT. It is T4 colon 1 slash TT. And T4 colon 2 slash TT. And this one is T4 colon 0 slash TT. Okay, I'll write the question again and then we'll match the solution. Okay, so we have three outputs, O colon 2 slash 0 and then 2 slash 1 and 2 slash 2. First, we have to turn on these two. Then we have to turn on this one only. Then we have to turn on these two. Okay, so we create it by checking the columns. So if we check the columns, 0. Okay, let me write T4 colon 0, T4 colon 1, and T4 colon 2. So we have to turn on this valve two times with 0 and with 2. So can you see this valve 0 is connected with 0 and 2. Then this output is again two times with 1 and 2. So it is connected with 1 and 2. This output, valve 2. Now the valve 3. This has to be turned on only once with which timer? 0. So if you see, valve 3 is connected with only 0 time. Okay. Now, this was the process to make the program. So once we make the complete program, or obviously we need to run this. So when we run this, we need to check the outputs, right? So if we check the output, look at this. First, this timer is going to run T4 colon 0 and it will give us two different valves, valve 1 and the last valve. Output 0 and output 2 mean valve 1 and valve 3. So the TT bit of this timer is connected 0 slash TT, 0 slash TT is connected with valve 1 and valve 3 only. So I guess it is clear, right, that how we do it. Now, the next output is T4 colon, the next timer is T4 colon 1. And this timer will glow only one valve, that is O colon 2 slash 1. So in this whole program, if you focus, this T4 colon 1 is used only once to turn on your valve 2. Then last timer is going to run. I'm changing the colors for the better understanding, right? So the last timer is T4 colon 2, which will turn on T4 colon 2 will turn on output 0 and output 1, mean valve 1 and valve 3. So if you see T4 colon 2 slash TT is used two times with valve 1 and valve 2. Now the time is to check the program, to run the program. Okay, so let's download to PLC and run it. Now you can see the outputs here also, or otherwise here also. I recommend to check the outputs here because after two or three programs, the programs are going to be very lengthy. So we will not scroll down to check the outputs again and again. We can check the outputs here also. So if I start, valve 1 and valve 3 is on according to the scenario. Valve 1 and valve 3 was on. Then valve 2 is on, and then valve 1 and 2 are on. Okay, I'll run it again. At first, valve 1 and valve 3 are on. Then valve 2, and then valve 1 and valve 2, and all stop automatically. Got it? So I guess this is clear to everyone. Now let's take another example. So now I'm placing four valves. Let me change the color. Let's take it a dark color. So now let's take another example of four valves. Valve 1, not valve, let's take pump now. So pump 1, pump 2, pump 3, pump 4. And the flow is what? First these two, then these two, then these three, and then these three. Okay, so we have to include 4 timers now: T0, T1, T2, and T3. Right? Again, check this way. Pump 1 2 times, 0 and 2. Got it? Then pump 2 3 times, 1, 2, 3. 1, 2, 3. Then pump 3 times, 0, 2, and 3. Then pump 4 2 times, 1 and 3. If your output is turning on multiple times, that means you need to connect the inputs in parallel, because T0 and T2 are independent to each other. Independent to each other in what sense? When T2 runs, TT bit high of only T0. When T2 runs, TT bit high of only T2. So we need to connect both timers TT in parallel to run this pump 2 times. Got it? So now I advise you to click a picture of this, because again and again I'll come to question solution. Question solution will take some time. Click the image. Even I am also clicking the image of this solution which we have made right now, and then I'll be making the program according to that. Okay. So now what I'm saying is we have to include one more timer. I said I am not coming to question again. You have clicked the image, so refer that one now. So let's take another, and then another timer. So it should be T4 colon 2, and it should be T4 colon 3. It should be 30 now. Now let's make the solution. So I'm opening my image. Okay, what we need is, let me first delete all these. We have another valve, another pump, sorry, colon 2/3, another pump. It is P1, P2, P3, and P4. So now we have 4 pumps, okay? And according to question, we have to first turn on the first pump with 2 different timers, T0 and T2. So let's make the solution. T0 and T2, which means T4 colon 0/TT, T4 colon 2/TT. Then T2, T2 3 times, T1, T2, T3. So let's connect 3 times. How we can connect 3 inputs in parallel? Let's see it now. Once you connect 2, select it, again parallel, and drag it here. Connect it here. And it is 3 times with T1, T2, T3. So need to write the address. It's T1, T2, and T3. Next. Now we have to run third pump 3 times. That is T0, T2, and T3. T0, T2, and T3. T0, T2. You can save your time by dragging the addresses, as I am doing. The last pump we need to turn on 2 times with T1 and T3. T1 and T3. So here we have T1, here we have T3, right? Simple. Okay. Now, when we run this, because this was the flow, how we made it. But when we run this, because we know when we run the program, the very first output we'll get is pump 1 and pump 3. Okay. Then pump 2 and pump 4. Then pump 1, 2, 3, and then pump 2, 3, 4. Okay. Let's check it. So download and run. Let me stop and start again. The first is pump 1 and 3. then is pump 2 and 4, then is pump 1, 2, 3, and then is pump 2, 3, 4. So that's how we completed this problem. I guess it is clear. Now I am giving you small task. You can do it by yourself, okay? Because someone was asking for a few exercise in the last session. So I'm giving you one small exercise, right? It's not always mandatory to keep all valves, all pumps, all motors. Your choice if you have one motor. Next, you have one pump. Next, you have conveyor belt. Next, you have a valve. Next, you have another motor. And next, you have another valve. So now we have almost 1, 2, 3, 4, 5, 6 outputs. Okay. Yesterday, when we understood about Micrologics 1000, there we were having only four. There we were having only four what? Only four number of outputs. But today, when we have this Micrologics 1400, we have around 12 outputs. Four outputs in 1000 and 12 outputs in this. But in simulation, we have around 32. So you can start using, you can start exploring, but unnecessary, you don't have to use any of the output. If it is required in your application, then only use it. Okay. So six outputs we need. So I'm just mentioning the address O colon 2 slash 0, O colon 2 slash 1, O colon 2 slash 2, O colon 2 slash 3, O colon 2 slash 4, and last is O colon 2 slash 5. Now let's turn on with T0, and first we have to turn on motor 1, then at the same time conveyor belt, at the same time motor, not motor 2, right? Then with T1, we have to turn on when motor 1 is off, conveyor belt is off. Then we have to run pump 1 and valve 1. Okay. And then when pump 1 off and valve 1 off, run motor 2 and valve 2. And then T3. At last, when we are making another combination, motor 1, conveyor 1, motor 2. So random. Okay. It's not actually the related example with any industry for now. We are not using any reference. We are just making it random problem to make it clear. So it's always not mandatory. If we have number of outputs 6, the timer should always be 6. No, that completely depends how many process we want. If we see right now, we have number of outputs 6, but only 5 processes are there. First process, second process, third process, fourth process, and then fifth process. Okay. So according to TT-bit, you can make the program. Just look at this output, O colon 2 slash 0. It is on 2 times, T0 and T3. So you have to make T0 and T3 in parallel for this one. Randomly, if I tell you about this, because it's exercise question, which you have to do yourself. So randomly, I'm telling. So if we see this output, O colon 2 slash 3, we have to turn on this 2 times, T1 and T4. So put T1 and T4 in parallel. That's it. Now do it by yourself. Okay. Take a screenshot of this or take an image of this so that you can complete this exercise by yourself. Now we are coming back to another part. Another example we are taking now. Okay. So another example is what? Let me clear this. Let's say we have a conveyor belt. Let me make it. Let's say we have a conveyor belt. I'm not good in drawing. And this conveyor belt is operated by a motor which is connected through output O colon 2 slash 0. And when we start using the start button, motor starts. And here we have a packet. Here we have a tank, say. Here we have a tank. So we have to fill this tank. We have to fill the liquid in this tank. Okay. So this one is the tank which has to move from this position to this position. And when it reach this position, we have to fill this one. So that means this tank already has the liquid, which is to be transferred from this tank to this tank. So this tank is in opposite direction, this way. So we need to keep the valve here. If we don't keep the valve, obviously the liquid flows out. So what we need to do, we need to put a valve here. So let's put a valve. Now, we are assuming, as we are doing the problem of timer, so we are assuming this for now, that this tank will take 3 seconds to reach here. Okay. And once this tank reach, we have to stop the motor and turn on the valve. Turning on the valve means we are transferring the liquid of this tank to this tank, which will take almost 2 seconds. To fill this tank, it will take 2 seconds. Once this tank is full, we have to close the valve and again start the motor and again start the motor to repeat the process. To repeat the process. So when we are talking about repeating the process, that means we need to run the timers again. We need to run the timers again. So first we need to understand one topic which is called reset of timers. Then we'll come to this question. Okay. So the next topic is reset of timers. We have two type of resets. The first one is manual and the second one is automatic. Okay. First, I'll let you know about the manual process. Manual using reset bit. We have one reset bit that is called RES. Like TT bit, enable bit, done bit, we have another bit called reset bit. And this reset bit will reset your timer. It will forcefully clears the accumulator value. If your accumulator is, let's say, 50, which is equivalent to preset, that means your timer completed the delay. But when you high the reset bit, it clears the accumulator to 0, mean it is being reset. Got it? Let's come to this. I'll show you it here. So we already have this program, okay? And this was with 4 pumps. And at last, I'm doing what? I'm keeping one reset bit. How to pick reset bit? Simply go to timers and pick one reset bit. As of now, we are doing manual operation. So what we need to do, we need to put a manual button. So I put a manual button and I colon 1/2 is to start. I colon 1/3 is to stop. So let's take I colon 1/4 to stop, to reset. And reset bit also asks the address. So which timer address we need to give here? So I'm writing it T4 colon 0. I'm doing reset. I'm doing reset for only one timer. That is the first timer. Why I'm doing only for one? Although I have to reset all the timers. Because if I reset first timer, if this timer becomes 0, obviously the done bit is going to be the low one. Why? Because done bit is high when preset and accumulator are equivalent, which means when the timer complete the delay, then done bit becomes high. So for now, if we have a timer of 3 seconds, preset is 30. If accumulator is also 30, that means the timer is completed. Done bit is high. But if we make this accumulator 0, obviously the done bit is low. And if the done bit is low, it will not pass the current to this timer. It becomes 0. As a result, it becomes 0, then this one, then this one, then this one. So ultimately, if we see, all these 3 timers are dependent to first timer. Indirectly, they are dependent to first timer. This one is dependent to this one, this one is dependent to this one, and this one is dependent to this one. So indirectly, all the timers are dependent to the first one, T4 colon 0. So if we reset only one timer, that is enough to reset the whole program for now, right? So that's what I'm doing. I put a manual input and T4 colon 0 as a reset. If I reset this timer, it will clear all the accumulators 0, all the timers 0, right? And again, the process will start. So let's start downloading and checking the code. Let's start it. If I see I colon 1/2, I'm getting 2 outputs. The next 2 outputs, timers are running here, you can see. Then 3 outputs and off. Right now, I want to reset as it's a manual reset. So I need to press which button? I need to press I:1/4. So I'm tapping this I:1/4 to reset. So if I tap this, I can see timer started again, right? If you keep I:1/4 high, if you hold it, which means you are holding the reset bit. And till the time you hold the reset bit, timer cannot go or cannot provide the delay. See, look here. If I hold this, you can see the timer is not working. Although it's getting current from here, but it is not working. Why? Because I'm holding I:1/4, which is holding reset bit, which is holding the accumulator forcefully to 0. But as soon as I release this input, timer starts again and I'm getting my outputs again. So this is called manual reset. Now, automatic reset, it is also simple. I have to reset the process automatically. How? Again, I'll do using reset bit. How I'll do this? Come to the point. See, I:1/4 is a manual input which I need to tap manually to reset the process. But if I want it automatically, what we can put? See, first this timer will run, then this, then this, then this. If this timer ends, the process ends. And after this, I have to repeat. So can we do one thing? If we put this timer's done bit to reset the whole process. So as soon as all the timers complete their delays, all the timers complete their timings, all the timer complete their task, it will reset the whole program to run again. T4:3/DN. So the last timer's done bit is telling us the program is completed. And when the done bit is high, it will make reset high and reset will reset all the timers. Now it is not holding the reset bit high. Have you seen? Have you noticed? I was holding I:1/4 and telling you the example. If you hold this input, reset bit is high, and till the time reset is high, timer cannot run. Although they are getting current, but they cannot run because reset bit hold the accumulator forcefully to 0. But done bit, with this done bit, it is not going to hold. Why? Because when you reset the timer, you resetting all the timers 0, 1, 2, 3. And when you resetting all the timers, third done bit is also getting reset. So third done bit will get low and reset will also will get low. And as soon as reset bit is low, the process starts again. This take time to understand. This take time. I mean, I'm briefing you. Think it is taking time, but when this process is going to happen, it won't take much time. Even I will say in milliseconds, you can see that the timer restarted again. So let me run this to understand. Stop and okay, stop and start. So let's see. First timer, then the second timer, then the third timer, and after fourth, you can see the first timer starts again. And again we are getting the outputs. So that's how we have successfully completed the reset of timers in two different modes, manual, automatic, right? So we will prefer automatic mode because we are doing automation, right? Now let's come to this question. So as I told you that in this question, we have what? We have a conveyor belt motor O:2/0, which has to run for 3 seconds, which has to run for 3 seconds for 3 seconds and valve for 2 seconds. Got it? And once the valve is off, again we need to start the process. You know, it's looking a difficult one because now I'm not making according to earlier I was giving you the problems like the timer problems which we have done that was in the form of arrows and 0, 1. But now when we look at this, it is uh, at first sight, it may become difficult for us, but actually it is very simple. If we create the program, if we make the diagram, basically, which we have made earlier in form of arrows, let's make the diagram for this one also. Okay. So if we make the program for a diagram for this one also, what we have actually, we have one motor, one valve. We have to on this for 2 seconds. Then we have to on this for 2 seconds. And then we have to repeat the process. That's what we have, right? And this is for 3 seconds, first timer, and this is for 2 seconds. So I guess now it is very easy, right? So if you are able to make this kind of diagram, you can solve each and every problem. So whatever problem you have in this form or in a theory form, just try to make it in this form and then it will be very clear to you. So now let's come to solve the problem. We need two timers. Let's delete this, delete this. We need only two outputs. So let's delete last two outputs. First one is motor. Second one is valve. Now this motor is on for 3 seconds and the valve is on for I have for 3 seconds. Let's delete. Let's delete this. Delete this. We need only two outputs. So let's delete last two outputs. First one is motor. Second one is valve. Now this motor is on for 3 seconds and the valve is on for 2 seconds. What we have to do? First timers TT to turn on the first motor and second timer TT to turn on the valve for 2 seconds, and then last timer is T4 colon once done bit to reset the whole process. Let's make accumulator 0 for now and run it. Stop and play. Motor on, conveyor on, valve on. Again conveyor, again valve. So now this process will go for infinity period of time, right? If we have to start counting how many tanks we have to fill, then we have to go for the next topic. Let's wait for that. Before that, let's try to solve another problem. Let's try to solve another problem. Let's say we have, now let me clear this first. Let's say now we have a single LED. Okay. Basically, we are going to make a program for emergency where we need to create a blinker. Suppose we have a LED and we have to turn it on, 6 times off with a delay of 1 second. So first then off, on, off, on, off, on, off, on, off, on, off. Let's count. 1, 2, 3, 4, 5, 6. 1 second on and 1 second off. We have to make this program. Okay. This is basically for blinker. Whenever we feel any kind of emergency in industry, we may turn on the alarms, or we may also turn on the LED in blinking mode. So that's what we are doing, but we are making temporary blinker, not the permanent one. Okay. So temporary blinker means we have to turn on the LED for limited time, limited span. Let's say for 6 times on and 6 times on, 6 times on and 6 times off, 1 second on and 1 second off. That's what we have to do. After that, we have to stop it. Got it? So if we go and make the program, only 1 or 2 timers are not enough to make it. Till the time, whatever topics we have covered, according to that, only 2 timers are not enough. We need to take around 12 timers because we have to do 12 process. On, off, on, off, on, off, 6 times on, 6 times off. So there are 12 process. So if we have 12 process, obviously we need to use what? Obviously, we need to take the done bit. Correct? We need to take, we need to take 12 timers, right? So let's come back to the screen and let me create 12 timers. I'll do it very fastly. If you remember, I told you yesterday that 5 parallel branches are allowed in Ellen Bedley, especially not in Delta, not in Siemens. Okay. When we talk about Ellen Bedley, only 5 parallel branches are allowed. So we can place only 5 timers in parallel, although we have to take 12 timers in this program. But for now, we can take only 5. So we need delay of only 1 second. So let's keep 10 everywhere. Okay, already we have connected 5 timers. More than that, we cannot connect. So let's copy the rung and place this after this. And now another 5 timers we have connected. Just need to change the address. 5 plus 5, now 10. T4 colon should be 5. 6, 7, and 8. Now 2 more we need. 5 plus 5, 10. Okay. 5 plus 5, 10 plus 5, 15. So we need only 12. Let's delete last 3 times. So it should be T4 colon 10, T4 colon 11. And here I'm making it T4 colon 9 and T4 colon 10. Let's download. Oh, not download. Actually, we have connected the timers, not the output. The LED is also required. So let's connect the LED, which we have to turn on. Right. So this time it is LED for emergency, and we have to turn on this 6 times on, 6 times off. Sometimes we may get confused when see this at first sight again. Although this is in the arrows form, I told you to make any problem in arrows form to make it simpler so that you can solve it easily. But still, when we look at this, because it's in arrow form, but this time it is in the horizontal way. That is the only thing that it is in horizontal. Otherwise, it's same like what we have done earlier. So let's try to make and solve this problem in vertical method simply. So we have a LED on, then off, then off, on, off, on, off, on, off, on, off. So this is with T0, T1, T2. Now, in the meantime, I'm doing this. Try by yourself what we can do and start commenting the solution for this. Okay, so we can see T0 to on and T1 to off, T2 to on and T3 to off, then T4 to on and T5 to off, and T6 to on, T7 to off. The same way we have to do till last, right? So if we have to turn on the turn on this LED using T0, if we look at this T0, turn on T0, T2, T4, T6, T8, T10, and at last, that's it, T10. So 1, 2, 3, 4, 5, 6. 6 times it is on. That means when we have to work with the TT bit, we have to take 6 TT bit in parallel. 6 TT bit in parallel. Alternate, starting from 0. So let's connect. Alternate, T4 colon 0 slash TT, 2 slash TT, 4 slash TT, 6 slash TT, 8 slash TT, and 10 slash TT, right? So this is according to what we have mentioned here, T0, T2, T4, T6, T8, and T10. We have to use these timers to turn on the LED, okay? And we are not using the bits of remaining timers because that time we have to keep this LED off to make a blinker. So let's run this. I know there are few problems in this, and I know you started commenting regarding the problems, but we will discuss those as well. First, let's try to run this. So I'm starting it, start counting. 1, 2, 3, 4, 5, 6, and it's off now. So now it's 6 times on, 6 times off. Solved using 12 timers. Okay. The very first question we have here, if we have not used T1, T3, T5, T7, T9, and T11 timers bit, then can we delete these timers? 1, 3, 5. Start commenting the answer, yes or no. Simply yes or no. Question is what? I repeat, we can see that we have used only 6 bits of alternate timers 0, 2, 4, 6, 8, 10 and skipped the bits of 1, 3, 5, 7, 9, 11. So can we delete those timers? Correct. We cannot delete the timers. Why? Because those, then third timer is turning on and fourth is turning off. Although we are not using the bit, that does not mean that we are not using the delay. We are using the delay of that timer to keep your LED off. Got it? Now, next point. Next point is we have 6 bits connected in parallel, but I mentioned only 6 parallel branches are allowed. Only, sorry, 5 parallel branches are allowed. Then how we can connect 6 parallel branches here? Yes, we cannot connect, right? So if we cannot connect 6 parallel branches, then let's connect this input here, delete this one, delete this one. Now, if we connect output here, this is also wrong. We cannot connect output 2 times. The same output 2 times we cannot connect. Why? Let's run. Before it runs, I'll give you the reason why we cannot connect 2 outputs in uh, repetition mode. Because if you turn on this output, see this and this, they both are same address. So let's say if we running the program and 0 timer TT bit is giving the output, 0 timer TT bit, that means this one is passing the current to make this output high. At the same time, this output is also high because this is same address, but it should not turn on because its input is not giving any current. I hope you're getting my point. I repeat what I said. When we run this program, let's say at very first instance, this timer's TT is giving the current to make this output high. And if this output is high, this is also high because they both are same address. But it should not glow or it should not turn on because this is not passing the current. So it is failing the logic. Somehow our logic is failed here because according to the logic, the output should be on if it is getting any current. But from the input side, it is not getting any current, and without current, it is turning on. We know it is turning on because of this output, but it is failing the logic, right? So that is the reason we cannot connect the output twice, right? There are some scenarios where we can connect, but that is called latching and unlatching. I'll show you those things just after understanding of this concept, right? So we cannot connect these 2 outputs in uh, repetition mode. If we run the program, see, we are not getting the outputs. Although they are passing the current, but because of logic fail, they are not getting on. So it's failing the logic sometimes and misbehaving also, right? It is also misbehaving because at last, when it is on, then it was on without any current. So it is misbehaving. So avoid repeating the outputs. You have to use binary here, B3:0/1. 0 we have used earlier with the start stop logic. So next binary is B3:0/1. Now let's put binary here in parallel to solve our problem. Now we have not connected more than 6 branches in parallel. Okay, more than 5 branches in parallel. Also, we are not repeating the output address. So that means each and every problem is resolved. We'll get the outputs now. So first, when these timers bits are on, binary is turning on the LED. And then when binary is off, here is also off, so LED is off. So this way it's working for 6 times on, 6 times off. Now I said we can repeat the output. Okay, how? Let me save this program. I'll open it again. Let's save it to desktop only. Blinker. Okay. Now, if we want to make a start stop logic, we can also use this technique. 2 inputs and I:1/2, I:1/3. Okay. And same output, O:2/0, 2/0. Now we can repeat because they both symbol are different. This is for latch, hold the output, unhold the output, latch the output, unlatch the output. Okay. So let's see. This will work, and here it is allowed to repeat. Output is on, output is off, on, off, on, off. I hope you get it, right? Now let's get back to the same program which we have just completed. Blinker. Okay. So this was the problem when we blinked it for 6 times on, 6 times off using 12 timers. Now we can also make the same program, not I mean the same program without 12 timers, with only 2 timers. But for that we need to understand another topic. Before directly jumping to that topic, I want to include the done bit also, because till now we haven't included too many questions, or only 1 or 2 questions of done bit. So let's include the done bit to solve this problem, then we'll go back to another topic or another problem. Okay, but before we go ahead, let's have a small break of 5 to 10 minutes, because I know, as per my experience of yesterday's session, a lot of participants have doubts during the session. So I'll come live to solve your doubts, and then we'll restart the session. Also, for now, I need a drink break. Okay. So after 5 to 10 minutes, we will continue. Take a pause. Meanwhile, I'll stop sharing, as I said earlier. Okay, guys, let me know if you have any questions or doubts. I'm waiting for your doubts here. Yeah, sure. Uh, how we reset the timer? See, basically, we use the reset bit to reset the timer, and the last uh, timer's done bit to reset your first timer, because we know all the timers are interconnected with each other. So the last timer is getting the current from the fourth one is getting from the third one is getting from the second one, and second one is getting from the first one. So that's how we reset, correct? So whenever you want to reset the timers, you have two different ways, although I have included only one here. And two ways are what? First option is to reset using the done bit, use last timer's done bit. And the second option is to put the done bits NC just after the binary where you are actually passing the current to your timers. Mr. Ankit, see, we can solve each and every problem using the T on as well, right? And the thing is that if you want to use T off, that's good, no problem. But if you want to use only T on, that is also fine, because each and every problem can be solved with the T on. T off is a quite complex one, so generally ये थोड़ा कम ही use होता है. How to get latch and unlatch? So basically, latch and unlatch are based upon uh, the same output, right? If you use the latch command and unlatch command, you can give the same address. So that means it's an advanced case where you can use the repetition of the same outputs. And latch mean it will turn on the output and hold the bit. And unlatch mean it will turn off the output and unhold the bit. Got it? So bit is what? Simply 0, 1. So once you turn on using a push button, so your output is on using the latch command. It's turned on and hold it. And when you turn on the other push button to make it off, unlatch command activates. Unlatch command unhold the bit 1, and it makes it to 0. So the for and at last we got output as 0, right? RTO timer used for holding for last position, and इसे reset करना पड़ता है. Actually, yes, exactly. You are right. RTO timer is basically used to pause the process. Like whenever you want to restart the process from the same position, you can use the RTO timers. And if you want to reset, because done bit, if you reset it using path break technique, it's not going to reset. You have only one option to reset, is reset bit for the RTO timer. Whereas with the T on and T off, you can reset those timers using the current brake systems or NC brake systems or path brake systems. Uh, at HP Instrument, I just recently gave the example of latch and unlatch. Recently, I gave the example in this video that you simply have to put one input with motor and other push button with the same motor, but use first push button to start and connect the latch command and other push button to stop and use the unlatch command. Okay, just wait for a while. If you want me to do it right now, let me share my screen with you guys and I'll be doing it. So look at this. Simply what I'm doing, I used one input and one latch command and other input and unlatch command, right? So considering that we have a motor at O colon 2 slash 0. So let's put the address here, O colon 2 slash 0 and O colon 2 slash 1, 0, same. So we are considering that this is the motor, right? And then I colon 1 slash 2 one push button, I colon 1 slash 3 other push button, right? So you can also use this one in the place of start stop logic. You can replace your start stop logic for latch and unlatch. Let's वहां यूज करना नेसेसरी हो जाता है मिस्टर अंकित वेयर वी हैव टू होल्ड द आउटपुट राइट. अगर आपको अपनी मोटर को होल्ड करना है तो ऑब्वियसली यू हैव टू यूज लेच अनलेच और द सेकंड ऑप्शन इज टू यूज स्टार्ट स्टॉप लॉजिक because using a single push button it's not possible to hold the motor for continuous time period. You need to hold the push button which is actually not possible. So हम क्या करते हैं बटन को पुश करने की जगह अपने आउटपुट यानी कि मोटर को ही होल्ड कर लेते हैं. तो होल्ड करने के लिए हम स्टार्ट स्टॉप लॉजिक क्रिएट करते हैं यूजिंग टू पुश बटन्स. एंड इफ यू डोंट वांट टू यूज स्टार्ट स्टॉप लॉजिक देन वी हैव सिंपल कमांड इज कॉल्ड लेच एंड अनलेच. सो सिंपली आई विल आंसर यू एज अ कंक्लूजन. लेच कहां पर यूज करना नेसेसरी हो जाता है जहां पे हमें अपनी मोटर को या अपने आउटपुट को होल्ड करना होता है. Any other doubts? Because I guess I have cleared all the problems which you have mentioned in the comment. Do we have any problems? Any other questions? Yes, Ankit, we can use the same output at different places. You can see here also I have used latch output O colon 2 slash 0 and unlatch O colon 2 slash 0. So if you use only latch, you can never turn it off. If you use only unlatch, you can never turn it on. So you have to use both latch and unlatch with the same output address, right? So which means कि आप एक ही आउटपुट को डिफरेंट प्लेस पे यूज कर सकते हैं लेच कमांड के थ्रू. बट अगर आप नॉर्मल आउटपुट लेते हैं तो उस केस में आप इसको डिफरेंट प्लेसेस पे नहीं कर सकते हैं. मूव इंस्ट्रक्शन को अभी मैं इंक्लूड नहीं कर सकता हूँ बिकॉज अभी हम कुछ और टॉपिक्स पे चल रहे हैं. सो नेक्स्ट जो ब्रेक होगा आप मुझसे उसमें पूछिएगा. आई विल मेक यू क्लियर. और अदरवाइज क्योंकि वी हैव टू इंक्लूड टू मेनी अदर कॉन्सेप्ट्स एज वेल फॉर नाउ सो इट वुड बी क्वाइट डिफिकल्ट टू अंडरस्टैंड फॉर अदर्स. बट इफ यू वांट आई कैन मेक इट राइट नाउ ताकि आपको ये ना लगे कि मैं आपको टाल रहा हूँ. राइट. आई डोंट वांट टू. Okay, I'm so sorry. I don't know about you because you asked the question in English and I was speaking in Hindi. I'm so sorry. So the point is that if what I said, we cannot include this move instruction for now, right? Because we have other participants as well who won't be able to understand the concept. But for just for you, I'm making a simple program. so that you can think that how we can do it. So we have to use two registers here. Now the point is registers other participants don't have idea about how we move the data from one register to other register. I'm just showing you here. So let's take integer files here, and I'm writing 6 here. If I tap the input on, you can see that the data from N7 colon 0 is transferred to N7 colon 1. Now for other participants, don't worry about it. Like we'll be discussing about registers N7 colon 0, N7 colon 1 very soon. Any other doubts? Okay, let's get back to. Hi everyone. Okay, let's start it again. I guess all your questions are solved. Fine. So before moving to the break, I was telling you about this 6 times on, 6 times off concept, and also the repetition of output is not allowed. Also, more than 5 branches are not allowed. So we have successfully understood the concept, right? Now, let's try to make a program to turn on this LED for infinity period of time. Turn on this LED for infinity period of time. Okay. So I'll edit the same code, say blinker one, right? And if we want this LED to turn on for infinity period of time, for the last one, we made it for infinite 12 times, 6 times on, 6 times off. So we put 12 timers. But that does not mean if we have to make it for infinity period of time, we have to include infinity timers. Obviously not, because we have reset bit, right? So how we can go for that? Simply, let's delete uh, around 10 timers I have deleted and included only 2 timers, right? And now what to do? Simply use first timers bit to turn the LED on, right? And use the second timers first timers bit to turn the LED on, and second timers done bit to reset the process. We already understood about the reset of timers, right? We have to reset once we get the delay of 2 seconds, mean 1 second on and 1 second off. So we can reset the timer. So as soon as the timer is reset, it will restart the process to blink your LED for infinity period of time. So let's see how it works. So it's working absolutely fine. On off for infinity period of time. It is 1 second on, 1 second off. We can also reduce the delay. Let's make it 0.5 seconds and zero point 0.5 seconds. So it is 0.5 second on and zero point 0.5 seconds off now. Correct? Okay. Now, I guess it's not quite difficult. It's easy to understand. And now we can shift to the next one. So let me open that blinker again, because before moving to the break, I also told you that we'll try to have this question using done bit. Okay. Now it is very important. When you change the TT bit to done bit, let's say if you change the whole TT process to done bit, what it will become? need to verify. Okay. I already know the result, but I want you to observe the result from your own eyes. Let's do it. So we have again set of 12 timers, delay of 1 second each. And at last, I have replaced all the TT bits with the done bit. Okay. Now let's see what is the output. So if we start the process, earlier when we were doing it with the TT bit, as soon as we start, the output LED was on. But now again, I'm starting. Just look at this LED. It is taking time to turn on, around 1 second. But last time when we turned on with the TT bit, as soon as we clicked this input, the LED was on. And secondly, the LED was on, off, on, off, on, off. Correct? But now the LED is continuously on. Two reasons for this. The first reason why LED take 1 second time to turn on, because once this timer done bit is high, which takes 1 second to complete, then only it will turn on the LED. And if the LED is on once, it is not going to turn off just because done bit never gets off automatically. TT bits gets off automatically just after completion of delay, but done bit never. Got it? So if we have to make this program with a done bit, right? If we have to make this program with a done bit, what we can do? First, let's save it with blinker 2. I'll come back to this. We'll get back to this problem again. But first, I am trying to solve it. I'm trying to tell you how we can replace the done bit in place of TT bit to get the same output. Okay. Yes, there is some accident outside. Very loud. I scared. Anyways, come back to the topic. So, what we have to do? I'm taking only one timer to make you clear how we can use the done bit in place of TT bit to get the same output. Let's take it for 5 seconds. Okay. I'll show you two different outputs. 1, 2. It's O:2/0 and it's O:2/1. Okay. Let's remove the labels. One with the TT bit and other with the done bit. We have already observed it, but let's see it again to recall. Sorry, to recall the concept. So if I start, if I run, we know TT will give you the output as it starts, but done bit will give you the output when it ends. And the output which you are getting with the done bit is not going to turn off because done bit don't get turn off and TT bit gets turn off automatically, right? But now I want to get both outputs same time. First output TT bit, but the second output with done bit. But same time, both should on, both should off without using TT. Okay. So what we can do, we have two solutions. Let's include enable bit. Okay. Now delete this. Want to get the output as TT bit. If I turn on, see both the outputs turned on at the same time. Last, we have to solve. Same time we turned on, but it was off automatically after 5 seconds when TT cut off, but it is not off because enable bit also don't get automatic cut off. Now we need to cut it off after 5 seconds. So just imagine after 5 seconds, which bit is going to turn on? done bit. After 5 seconds, done bit is going to turn on and done bit is going to high if we use the NC of done bit. If we use the NC of done bit. Now, what is the scenario? Initially, let me take this to the picture. Okay. So initially, when enable bit is on, this one is NC, this one is also NC. When enable bit goes high, it becomes NC. This is already NC. So both are passing the current to make this output high. Which output? This output. And once the 5 seconds of delay is completed, then bits gets low. Then bits get high. So this NC will become NO, right? This will become open. We know if we take NO and the bit is high, any bit, this become close. And if by default we take NC and any bit become high, it become open. Same scenario we have used here. Start stop. We keep it on to make this NC both pass the current, logic starts. But when we keep this on, it become NO, stop the path for the current and output become low. Same we are using here. So we will use the NC of done bit. Initially, it will pass the current. It will allow the current to pass. But later, once the done bit is high, it become open and break the path for the current. Ultimately, the output gets low. Right? Now, let's run it. This is the solution to get TT bit. Start. Both output high at the same time. Both outputs should low at the same time. So we have solved it. Now the question is, sir, why we are doing this TT done, TT done? Why we are like making it so confusing? Let me clarify you. When you are working with the Allen Bradley, you have three options: enable, TT, DN. After Allen Bradley, you have to jump to Siemens, maybe Delta, okay, maybe Mitsubishi, or maybe any other brand. You know what? Which bit you are going to get there? Only done bit. Only done bit. So for now, the problems are getting solved very easily with the help of TT bit. But when you go with the Siemens, Delta, and Mitsubishi, there we have only done bit, and we have to solve each and every problem using only and only done bit. So now I'm trying to make your concepts according to Siemens, because very soon we are going to jump to Siemens as well, right? I hope it is clear what I said. So this problem is solved. If we have to make the solution for TT, we can take one NO and one NC combination, NO of enable and NC of done bit. This whole will give you the replacement of TT. Now the point is, sir, you just said only done bit. Then if in Siemens we don't have enable bit, what will be the solution for this? Okay, let's solve this one also. Come to this. Now we know about enable bit. Enable bit is a kind of manual bit. When we start the logic, it turns on. When we stop the logic, it turns off. If you don't remember, let's put another output. Okay, let's put another output to observe what enable bit is doing. Only enable. Okay, and another output. Just to observe. Although we have completed this yesterday, but let's recall. So we have to focus this time only on third output, which is through enable bit. If you start, enable bit goes on. After 5 seconds, it is still on. See? So this bit is basically a kind of manual bit. When you turn on, it's on. When you turn off, it's off. Look at this, it's off now. When I turn on, it's on. When I off, it's off. So it's a manual bit. So what we can do, we can take binary also in place of this enable bit. If we take binary, we'll get the same, because binary start the timer and timer starts the enable bit. So that means binary is enabling the enable bit. And when we close the binary, it's disabling the enable bit. So enable bit is equivalent to binary, right? So if I start, let me download and run. Start, enable bit mean binary on. If I stop, binary off. So we got the solution for TT bit now. Okay. So now if we don't have enable bit and TT bit, we can make the solution, right? When we talk about Siemens, Delta, Mitsubishi, there we have only done bit, so we can make the solution this way. So if you say binary is also not there, yeah, I agree, binary is not there, but binary, I mean, binary is there, but with a different name. Same property, but with a different name. It is called memory bit there. Okay. Different addressing, but working scenario, each and everything same. That will come to that point when we start the Siemens one. Okay. Because I already told you once we complete the concepts of Ellen Bedley, it won't take much time to understand the concepts with the Siemens, right? I hope it is clear what is the solution for enable TTDN, right? Now let's come back to that question, because right now we understood this with only one timer. Now when we have the scenario of solving multiple problems, this was the problem which we just did, 6 times on, 6 times off, but we have to solve it with the done bit without using TT, without using enable, right? So how we can get solution for this without using TT and enable? So at first, I'm putting binary bit B3 colon 0/0 to make the solution for first timers TT bit. So these two are equivalent to first timers TT bit. Solved. Now what about the second timer? Because if I put a binary bit here again and make the solution this way, this is the solution for first timers TT. Is it the solution for second timer, third timer? I mean, T4 colon 2 timer TT? No, because if we keep this way, binary will start initially. These all are NC initially. So they all will pass the current. That means output is not going to low ever. So when we make the solution for this, the TT bit for the next timer, let's say this timer starts using this binary, right? And this timer start with this timer. This timer starts with the help of this timer. We got the solution, I guess. I'm giving you a hint for now. If this timer start because of this timer, so we can use done bit of last timer as a start point of this, as a binary of this, as a enable of this. If you compare the enable bit of T4 colon 2, when it goes on, when it starts, and when it starts, when 1/done on, because 1/done is responsible to turn this on. Like binary is responsible to turn this on. So binary is working as an enable bit for this timer, right? Then this timer done is responsible to turn on this timer. That means this timer's done is working as an enable of this timer. Same, this timer's done is responsible to turn on this timer. That means this timer's done is responsible and it is working as an enable of this timer. So now we get the solution. And what is that? Let's keep it in a simple way. Last timer's done and NC of itself done is equivalent to TT bit of this timer. T4 colon 2 TT is equivalent to this combination. Last timer's done and NC of its own done. Now for this, what should be? Last timer. We are talking about 4 now. So it should be 3 done. Last timer's done is 3 for this. Then now we are talking about 6. So last timer obviously is 5. Then when we're talking about 8, last timer done is obviously 7. And when we're talking about 11, last timer done is obviously 9. So now we get the solution for the replacement of TT, and now all the concepts are cleared. If you have any questions, put your comments. I'm not going for the break, but still, if you have any questions, I'll pause and take your questions. Let's start. It's working same like earlier. 1 second on, 1 second off with the help of only done bit. No TT, no enable. Solved. Okay. Now it is the time to move to the second topic. Next topic. So we are done with the timers for now. Okay. Now let's try to reduce this problem because we are using 12 timers to turn on this LED 12 times. So what next we can do? Also, we have done one problem of packing scenario, filling scenario where we had a tank and we moved the tank from one place to other to fill it. Then the valve was opening for 2 seconds and we were repeating the sequence. So if we have to repeat the sequence and almost say for 10 times or 20 times, we have a production line there. We have a target of a day to pack or to fill only 100 bottles, let's say. So after 100 bottles, we have to turn off the process, the whole process. How we can do that? For that, we need to understand the next topic that is called counters. Okay, so let's start it. Let me come front. So next topic is counters. Two type of counters, CTU, CTD. CTU is called counter up and CTD is called counter down. Okay, now counter up or counter down, they both are 16-bit, which means 2 to the power 16, which has the value maximum and minimum minus 32768 plus 32767. Okay, and after this, if we write the address of counter, it is C5 colon 0 to C5 colon 31. We have 3 bits, CU, CD, and DN. I'm talking about only 1 bit, that is done bit. That is done bit. Okay, and currently I'm talking about only one timer, that is C5. So the address of counter is C5 colon 0 to C5 colon 31, and there are 32 counters. And we have a done bit, right, of CTU as well as CTD. So done bit address is C5 colon X slash TN. X is what? The address of counter. For now, it is 0 to 31. It can be anything between 0 to 31, depending upon which one you are using. When the done bit is high, when you complete the count. Counter is basically to count the process. Counter is basically here to count the process or to count the number of products. Okay. And we can maximum count up to minus 327682 plus 32767 because we have 16-bit of counters available. Address are these. And 10-bit become high when your count completes according to CTU I'm talking about. So without wasting time, let's come to this and let's start a new file. We'll come back to this problem again once we understood the concept of counters. Okay, so let's take an input and let's take a counter. This time we don't have to take a start stop logic to count because counter need what? I'll show you. Better I'll show you, you'll understand. If we keep this input on, counter accumulator goes to 1. It is not going to be like timer 2, 3, 4, 5 because it's not timer giving the delay. It is counting the process. So whatever input you connect with the counter must go on off, on off, on off to give it different pulses, right? I will compare both timers and counters. When we talk about timers, timers need continuous current to operate, whereas counter don't need continuous current to run. Let's take the example to understand this. Let's say, let me take one next. Yeah, this one. Let's say this is a sensor, okay, and this is the object. This is the object, right? So this is a sensor and this one is the object. If we keep the object in front of the sensor, sensor detect the obstacle, sensor detect the object, it will count it. Okay, it will give the signal to counter as 1. But as soon as this object passes, this is a conveyor belt, object is moving. When object is in front of the sensor, it is giving the logic to counter to count 1. But when object move, sensor value becomes 0. So now it is not giving any logic to counter, right? Again, a new object came into the scenario. Now sensor again senses the object, again giving the logic to counter, which make the counter value 2. Again, object moved and sensor becomes 0. That means for counter, we need a kind of input which is on off, on off, on off. Right? We need all the pulses, on and off pulses to run the count. Most of the time, when we count the products, we have a sensor which give 1-0 logic, right? So that means now I need to push it around 5 times. For now, manually, we need to push it 5 times to count 5, right? And as soon as the 5 counts are completed, the done bit become high. Let's connect one done bit and output to cross verify this. See, done bit is high. I need to make the accumulator 0 to run again to show you the process. 1, 2, 3, 4, and 5. Done bit is high, right? Now, if we have to reset, two type of resets are available. Manual reset. So for manual reset, let's take another input I colon 1/3 and a reset bit, that is C5 colon 0. So now if I run this, stop. I mean, not stop, it was the reset now. So 1, 2, 3, 4, 5. If I keep the reset bit high using this manual input I colon 1/3, it is resetting the process, making the accumulator to 0, which means done bit is 0, output is 0. I hope it is clear. Counter is very easy topic to understand. It don't take much time to understand. Okay, so counter understood, right? Now let's make it automatic reset like the last one. Now I'm putting counters done bit to reset. But this time it may create problem to reset because timer we can reset using the done bit. But counter has the problem in especially in Ellen Bedley. 1, 2, 3, 4, and 5. Have you seen? Have you noticed? Note it again. The counter's value is 1. Now I put an input 2, 3, 4. Now it is important to watch what's going to happen. If I click it once for the count 5, it become 1. What is actually happening? Why it is happening? We need to understand that. As soon as I'm clicking the fifth input, the counter accumulator become 5. And once the counter accumulator is 5, obviously we know the done bit is high. If the done bit is high, reset bit is high. If the reset bit is high, it makes the accumulator 0. And when accumulator is 0, it is considering your fifth input as a first input. That means you pushed the fifth input, you tapped the fifth input, and too many things happened at the same time. Before you release the fifth input, what are the things happened? Fifth input, make accumulator 5, make done bit high, make reset bit high, reset bit make the accumulator 0. All these things happened when you tap the fifth input. And before you release, when accumulator was 0, it considered the fifth input as the first input and made your accumulator 1. This is happening because counter is not getting enough amount of time to understand. These are high speed counters. This is called HSC, high speed counters. We have here high speed counters. That's why that is considering fifth input as a first input, and after resetting, making it to 5, making it to 1 directly. Correct. So if we put this way and reset the counter, obviously we know that it will count 1 less than your desired number. If you say you have to pack 5 products, it will pack only 4 products. and reset back to 1, not to 0. If it reset back to 0, that would be fine. So we have two different techniques to solve this. The very first technique is very simple. We already said the counter is not getting enough time to understand between the fifth input and the first input. It is considering your fifth input as the first input. So we have to give it a time to think about it, that it's not your first input, it was your fifth input. Got it? So if we have to give time, obviously we need to include timer. So let's include a timer, counters done bit, and a timer, and not too much of time. I'm putting it around zero point 0.5 seconds. And then once the 0.5 seconds delay is over, then we will ask what we deem, oh sorry, once the zero point 0.5 seconds are over, that means the done bit is high, then we will ask it to reset the counter. So counter will become 0 after a short break of 0 0.5 seconds. Now look at this. This is the first solution which we are doing. 1, 2, 1 was already there. I'll do it again once it becomes 0. 3, 4, 5. And now it is 0. Because now it gets time around 0 0.5 seconds. In the meantime, we left the input and it becomes 0. Correct? But if you don't left the input, if you hold it for long time, let's say for now, I'm holding it. 1, 2, 3, fifth input especially I'll hold 5. If I hold it, it come to 1 because now it considered it as the next input. If you hold it for long time, right? Although this is not going to happen in the scenario when you're working with the products because they move very fastly, right? But let's consider if this happens, then what is the solution? So let's delete this solution for now. Okay. What was the solution? We have to include a timer of 0 0.5 second and then with timers done bit include counter reset. Now, next solution. We will reset again with the help of counters done bit only, but we will reset only once you leave the input. Till the time you hold the input, it is not going to reset. Just try to understand this now. See, when I hold the input, this NC become open. It is not passing the current, right? At fifth input, it is important to understand. See, it is 4 now. Now, when I tap fifth input, done bit is high, obviously. When done bit high, it become close. But when you hold the fifth input, it become open. So till the time you hold it, it won't pass the current. That means done bit alone cannot pass the current to reset. So once you leave, then only it will reset. And once you leave, obviously it go to 0, not to 1. Let's see it again. 0. Okay. 1, 2, 3, 4, fifth input. See, I'm holding this input. Accumulator is 5. Done bit is high. It is not resetting because this is not allowing the current to pass. It will allow the current to pass once I leave this input. So I leave it. It became NC. It became NC. Reset. Reset is 0. Once it is 0, done bit is 0. It became open. So everything is reset. Now you have two different scenarios to solve this problem, right? I guess it is clear how we can reset the counters. So now let's come back to the problem, which was blinker. This was TT bit. Okay, let me open another program. Blinker 1. This was with the TT bit again. Okay, let's open blinker 2. Okay, this one. I guess that program is deleted. Yeah. Okay, no problem. We'll make it in a minute. Won't take much time. Only we have 3 backups. So now we will do what? We have to turn on LED. Okay, and that is only for only with 2 timers and for 12 times. This we'll be doing now. 2 timers, 0, 1, one LED. Let's turn it on using timer 0 done bit. And when we use done bit, we need to make it a combination because it will turn on after 1 second. So let's make a combination with binary bit to make a TT. So while we're running the timer, that time we should get the output. Make it NC and then make a reset. Each and everything I have cleared recently. So I'm including all those concepts which I told you. T4 colon 0. Okay. This is the combination of infinity timer infinity blinker, right? We have to make it 6 times on, 6 times off. Just give me a moment, then we'll make it. First, let's try to understand. We have already completed this program as well. Now we have to make 6 times on, 6 times off. Earlier, we made 6 times on, 6 times off with the help of 12 timers. But now we already understood one topic of counter. So let's make it 6 times on, 6 times off using only 2 timers. How we can make it? Let's come to this and let's start counting the process. T4 colon 1 slash done is counting the process. So how many times we have to count? 6 times on, 6 times off. Total 12, but count 6 times only because we are counting through this timer's done bit. This timer's done bit mean what? When it is on, it is turning on the output. When it is on, the output is off. That means on off process is completed. So this way, when one time on off is completed, this timer done bit become high. It will count it as 1. So 6 times on, 6 times off means 6 on off process. And if 6 on off process we have to do, what we can do, we know it very well. Once 6 counts are completed, counters done bit will become high. And that time we have to stop the whole process. So to stop the whole process, let's include what? Let's include counters, done bits, NC here. Because after 6 count complete, done bit become high and this NC become NO, right? So it's already counting there. If you can see 3, 4, 5, and 6. Let's run it again. Okay, it's not going to run because done bit is open. Done bit is open because counters done bit is counter value is 6. So I need to either make it 0 or I'll give you another solution for that. So 1, 2, 3. I'm counting from here. 4, 5, 6 time on, and after this, it's not going to turn on. 6 counts completed. Counters done bit high. So this become open, and if this become open, it will break the path of binary. If binary path is break, all timers are not going to run. Okay. So what I told you, if you want to reset sometimes, see this program was only for once. 6 times on, 6 times off, done, completed. It's not going to work anymore. It will work if we go offline, clear the accumulator, download it again if we run it, it will work. But this is simulator, the process is very simple doing it, right? But when we're working with the actual scenario of the industry, every time we cannot go offline to make the process reset. We have to make it uh, reset during the online running of your code, right? How we can do that we need to understand. So for that, what we can do, first let me tell you the solution with the simulator. Then I'll tell you the solution for the hardware. Let it get complete. So 6 times on, 6 times off, done. If I want to start again, it's not happening, right? I can go offline, either make accumulator 0 or other solution, because this will help you if your simulation is not working. Sometimes when you facing the errors, simply go to simulations, reset the simulation, reset timers and counters, reset, clear all tables and files. So this will clear the simulation, each and every value to the reset point, to the 0 point. Now it is active again to run. Okay. And if you want to make a solution for the run mode only, during run mode, you want to start it. So how we can start it? Let's come here. See, we need to simply reset the done bit of counter manually. Don't reset the counter automatically for this program. If you automatically reset after 6 times completed, it will start again counting 6 times. Then again reset automatically, then again it will count 6 times. So that means it's not going to stop after 6 times on, 6 times off or your of your LED. It will keep going six, 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 six. This way it will go to infinity period of time, right? So don't take it, don't take any uh, automatic input for counters reset. So I'm placing I:1/4 for manual input to reset this, right? So 2 is to start, 3 is to stop, and 4 is to reset. So 4 is to reset, 3 is to stop, and 2 is to start. I started it, working fine. Let's count it for 6. Once it is done, I will reset and repeat again. 4 to reset and 2 to start again. Okay. In between, if you want to interrupt, stop it. Third input you have, right? Now I have a point. I can also do one thing. I mean, we can also do one thing. That is what? Why to use another input? I have already told you, let's try to reduce the number of inputs used. Unnecessarily, we don't have to use any input. I know we need an input to manually reset the counter, but we can also use two. At the same time, when we start, it will reset the counter. Every time we start, it will reset. Two benefits. We not need to press 2 times. Earlier, we were first clicking this button to reset and this button to start. Now we not need to press it 2 times. We will start, it will work as a start as well as reset, right? Let's see now. I clicked it, reset as well as start. So with only 2 buttons, we have solved this problem. Okay. Now let's try to make it more shorter. I hope these things are understood in a very well manner. Now let's try to understood this in a short manner. First of all, I'll do what? I'll make a program because currently we are talking about reducing the number of inputs. So first let's reduce the number of inputs here. Okay. So let me save because I'll come back to this one. Blinker 4 I have done. Is it saved or not? Let me check. Yes, it is saved. Okay. Now let me save it one more time with blinker 5. Got it. So now I am making a program for start stop logic. You remember when we started, I'll come to this, deleting this. When we started this PLC understanding yesterday, I told you one scenario. We have a motor. We have a motor, and if we turn this on, we can take a toggle button. So toggle button will keep it on, and when we want to turn off, we can keep this button off. But if toggle is not available in spare, we can make what? We can use direct input. But direct input was giving the issue. If we turn on this button, it will keep motor on until we hold it. So we used one scenario of holding the motor. That means if this motor has the address O:2/0, we made it O:2/0. But there was the problem. If we turn this on, motor goes on, but to turn off, this single input is not sufficient, then we need to take another input I colon 1/3, right? This one I'm talking about. Means start stop logic I am talking about. That is a different thing. Later on, when we use the timer, we replace this to binary. But currently I'm talking about motor. So obviously we cannot take binary. For motor, we need to take real-time output. And real-time output is obviously output address. So when we started with toggle button. If toggle is not available in spare, we can use two direct inputs, right? And yesterday only I told you we can make start stop logic using one input as well, one direct input as well. What I mean to say that we will use only one input, that is I colon 1/2 to keep motor on and off as well. So if we tap it first time, it will keep motor on. Second time, motor off. If we keep third time, motor on. If we keep fourth time, motor off. This way it will go, right? So how we can make this program? Let's come to this. So I'm directly deleting this. I have only one input now and one motor. Till now, this concept is clear that if we turn on this button, it will keep your motor on. If we turn on this button, it will keep your motor on and hold the value and hold the value. But we have to keep this motor, we have to turn this motor off when we press it again. But currently it is not going to happen. Let's see, and then we'll find a solution. See, the motor is on, but when we tap it again, the motor is not off. So let's try to find out the solution for this. Okay, so what I'm doing, I'm taking a counter and counting it for two times, only two times, right? Because it is not possible first time on, third time on, then fifth time on, then seventh time on. So we cannot count it till infinity, right? So because the process is happening what? On off, on off, on off. So let's make it two times only. And two times will help us what? When you tap this very first time, output become high, correct? Output is holded here. That means the logic is started, motor is started, and at the same time, the counter value is 1. Because you turn on this input once, first time, motor on, and counter value become 1. Now, when you turn this input second time, you want this motor to turn off. But it won't affect this logic because it is already passing the current, and with the help of 2 you are again passing the current, although you have to break. That is why we used this third, which we don't have to use right now, correct, to break the path. But just look at the logic. When you press this button first time, it hold the motor and make the counter 1. But when you press this input second time, no effect on motor, but counter become 2. And here it is important part. When counter become 2, counters done bit become high. And when counters done is high, we can break the path using NC of done bit. Let's look at the logic and try to run this. One, two, motor is off. Start, stop. But it is not going to work after two times. Why? Because two times, when you tap the input two times, on, off, two times are done. So now it won't work because counter value became 2 and then counter done bit is already high, which means it is permanently break the path. So we need to reset the counter and automatically we need to reset the counter. And I gave you two different ways to reset the counter. So let's use the second one. Let's take inputs NC and a done bit of counter to reset the counter. Recently we have done this. Now, once the counter is reset, your logic is ready to start again for the start stop. So start 1, stop, again start, again stop, again start, again stop. Working absolutely fine. So now we have successfully built a logic of start stop using only one single direct input. Got it? If you not understood this concept of resetting, then I gave you another concept of resetting, that was take a timer T4 colon 0 and small delay of zero point 0.5, and then timers done, and then a output, that is O colon 2 slash 0. Sorry, not output, reset. C5 colon 0 we need to reset. If you reset C5 colon 0, timer is also going to reset, because timer is connected with the done bit of counter. And once the counter is reset, timer is reset. So one, on, off, on, off, on, off. We have completed this as well. Okay. Now the last code, because now it's the time when we have to move to Siemens as well. So the last code we are doing here now, that is, let's come back to Blinker 2. Not this one. Yes. So this code we just created a while ago, and it was for 6 times on, 6 times off, using only two timers, right? And one counter we used here to count the process. Now let's take a new file, because now I'm going to make this program in a short manner. As I said, we'll make it in a short manner. And to make it in a short manner, now again, I'll be doing 6 times on, 6 times off, using only one time, Okay. File, new. See, we have 40 timers. So it does not matter if you use two timer, one timer, 12 timers, right? It will increase the size of the program, and accordingly, uh, your PLC load would be a bit high, but not that much high, because enough memory we have there. Okay. And the programs we are writing is already in KBs, so does not matter. Why I am doing this two timers, one timer, so that you can understand the importance of other topic. Okay. It is important that if we use two buttons, and in place of that, if we short it to one button, that is necessary part, because that is hardware resource. We cannot waste it. In the hardware, we have limited number of outputs. But when we're talking about the timers, they already in the software. So we can use up to 40 timers when we have the option. And now in this PLC, I have the option up to 128 timers in this one on my backside. And even this have all the features of bit base time 1.01, 0.001, and 0.0001. I told you yesterday during the theory session of this timer, right? So it is important, because I am telling you the importance of next topic, and through that you can understand how you can short the code. Okay. So now let's create a new file to understand last problem through last topic of this Ellen Bedley. Let me open this. I guess it's again 1 hour I'm continuously speaking. So let's have a small break of 5 minutes, and then we will start it again. Meanwhile, if you have any questions or doubts, you can continue with the live session. Okay, guys, if you have any questions or doubts, you can ask. Let's continue with the doubts and problems which you may have. I'm waiting from you guys. If you have any questions, please write on the chat box. I'm live here, waiting for your response. If you have any questions, please ask. Hi, everyone. Okay, I guess no one has the doubts, so let's continue. Functional block diagram. It is called FBD. And first, we are starting with compare block. We have too many things here, but unfortunately, we cannot cover each and everything. So I'm looking forward for the compare, and there we have a block called limit block. So I'm going to cover only one block for now. Other than that, we have less, greater, LEQ, NEQ, and EQU. And yeah, an MEQ block as well. But for now, I'm going to cover one block that is called limit block. Okay. So, what is a limit block? Limit block is going to work as input. Compare block work as input, mean N over NC. We have three different options: lower limit, higher limit. Sorry, this one is test value, and higher limit. Right? So, how this block work? If the lower limit is less than equals to test value is less than equals to higher limit, this block work as NC. Otherwise, it is going to work as NO. What we are going to compare here, as these are compare blocks, so we can compare the real numbers. We can compare the integers, which is called int, right? The data type for the PLC for this is int. When we're talking about these two things, the data type is Boolean. Boolean mean 0 or 1. 0 mean NO, 1 mean NC. Come to this. So we use this limit block to compare the real numbers. And what we said, if the lower limit is less than equals to test value is less than equals to higher limit, it works as NC, otherwise works as NO. For example, if I keep 1 here, if I keep 10 here, so if your test value is in between 1 and 10, let's say if it is 1, it works as NC. If it is 2, NC, 3, NC, up to 10, it works as NC. But when the value is 11, 11 is basically out of the range of lower limit and higher limit. So it becomes as NO. Got it? Second thing, if we have to not the second thing for now. Let's first make it compare limit and output. If I make it, I'll tell you again how I did it. We have to go to this compare. There we have limit block, then take output. If lower limit is, I said 1, test value I said 5 per se, and if it is 10, then the output is O colon 2 slash 0. So currently 5 is in the range of 1 and 10, in the range of lower limit and higher limit. So it works as NC, so the output is high. Now let's make it 15. Now it is not in the range. Download and run again. So the output is low. Correct? Now it is not in the range. The output is low because it's working as NO. Now, if we have to check the values, like I'm changing the value, coming to PGM mode, changing the value, let's say 6, then I'm again downloading it, again running it. So if I don't want to come to PGM mode and want to put the value in online mode, it's not working. Can you see? I'm tapping it again and again, but it's not working. That means it does not allow to put the value in online mode. If you take constants like this, but if you don't take the constants, there we have another option that is called integer files. What is called? Integer files. Integer files are what? N7 colon 02, N7 colon 100. We can store any integer number with these data files. We have gone through input, output, binary, timer, counter, and now integer files. And when your data is not integer, when it is decimal, then you have float files. F8 colon 0 to F8 colon 100. Okay. F8 colon 0 to F8 colon 100. So if you take these files, it will allow you to change in this run mode as well. Right now, let's do it. So I am changing it to N7 colon 0, N7 colon 0, N7 colon 1, N7 colon 2. These are basically integer files, or let's say registers. Registers we use to store the data temporarily. So these are the registers which will hold your data temporarily. So let's download and run. Now the point is how we will assign the value. If we double tap here, it won't allow us to put the value. So let's close your simulation from here. Here we have the option of data files. There we have the option of integer. Open this. Once you open this tab, drag it and double tap here. Let's say the lower limit N7 colon 0 is 1. Can you see the 1 is assigned here? Higher limit is 56. Now let's change the value of the test N7 colon 1 continuously. I'm keeping it 5. The output become high because it's working as NC. 5 is in the range of 1 and 56. If we change it 67, now 67 is not in the range of 1 and 56. So the output is low because it's working as NO and we are changing everything in the run mode. Got it? So this is the way how we can apply the changes. Now, what is the use of this block in reality? Like if we have to compare, come back to this. If we have to compare timers or counters, if we have to compare timers and counters, we can directly put the timers and counters accumulator address. This is timers accumulator. This one is counters accumulator. Timer and counter also have integers, and those are what? Preset and accumulator. So this address is for timer accumulator. This address is for counter accumulator with a reference of timer 0 and counter 0. If timer is 1, this address is P4 colon 1 dot ACC, C5 colon 1 dot ACC. Now, second point is what? If we have to take preset, the address is P4 colon 0 dot PRE and counter is C5 colon 0 dot PRE. So that means for PRE, you have to put dot PRE. For ACC, you have to put dot ACC. PRE means preset, ACC means accumulator, right? Now, let's take small example. I guess someone asked me in the yesterday's session that how Not someone asked me, actually, I gave the example. If we have to take one single timer and take four different outputs, we have to divide that timer into four parts. How we can do that? So that's what I'm doing here now. I colon 1 slash 2, 1 slash 3, D3 colon 0 slash 0. And then I'm taking a timer for, let's say, 120. That means 12 seconds. And let's put it O colon 2 slash, not O colon. So sorry, it's binary B3 colon 0 slash 0. Here, I want what? I want four different outputs, 3 seconds each. Third, 3 seconds each, four timer continuously, each after one. So what to put here? I said when the timer accumulator is 1 and the higher limit is 30, then test timer's accumulator. So when you run the timer, it will keep changing these values. Accumulator is going to change obviously from 0 to 120. So when it become 1 to 30, then this output goes high. Same ways, copy this, paste, 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 right? So the first output is 1 to 30. Now let's say the second output is 31 to 60. And third output is 61 to 90. And the last output is 91 to 120. Let's change the output address as well. 0, 1, 2, and 3. And then at last, let's reset this with a done bit. T4 colon 0 slash DN, and reset is what? T4 colon 0, because we have only one time. Okay. Now let's download and run. So only one timer is going to give you four different outputs. Sorry, this should be three. I made a mistake here. So only one timer is going to give you the outputs for four different outputs. Each 3 seconds, one by one simultaneously. And repeat it. Okay. So this way, now we shorted this code. Okay. Now come back to the last code, which we were about to make shorter. I guess it was blink 4. Yes. 6 times on, 6 times off. We made it using two timers. If we have to make it using one timer, so let's delete this. Let's delete this. Let's delete this. 1 second on, 1 second off. Total time period is 2 seconds. So make it 20. Okay. And now we cannot, based on this TT bit, combination of TT bit, right? So now we cannot, based on this, because TT bit or this combination is going to work for whole 2 seconds, and we have to turn on the output only for a second. Earlier there were two timers, so we were dependent on this, but now we cannot. So now we need to change this block to the limit block. And what we said, when the timer accumulator is from 1 to 10, keep the output high. And when the accumulator is 10 to 20, keep the output off. So 1 second on, 1 second off. And once this timer is completed, reset the whole process. Also start counting this process and then turn off everything after 6 times. So now we have used only one timer. Started working fine, but it's not counting because when done bit is high, it's resetting, but done bit is not able to count the process. Why? Because once your done bit is high, once your done bit is high, it is at the same time resetting the process. So now it's not able to count, right? For that, we need to use something else. So what I'm doing here, let's take another block, one more block you are getting as a gift from my side now. That is equal to block. Equal to block works when the source A and source B become equal. So I'm saying when timer's accumulator becomes equal to timer's preset T4 colon 0 dot PRE make a count. No, it's not also working because the accumulator is not going up to 21. We need to change it to 20, not going up to 20. Let's make it 21 because at 20 it's resetting, and as soon as it becomes 20, it's becoming 0. So it's not counting. Again, same thing happening. So now try to solve it by yourself, or you want solution from my side. Also try to include only one direct button. This is two buttons. I already told you the logic for that as well. So you can make that one also. So we have to count. Okay. What we can do? Let's not reset this way. This is not equal to block will work till the time accumulator is not equal to 20. Once the accumulator is 20, it will reset the process. And I'll count when accumulator become 20. Let's see if it works. Yeah, it works. Now it started counting. Timer accumulator is 20, it's counting one. Timer accumulator is 21, it's resetting. So this not equal to block works in opposite way. It will pass the current if timer accumulator is not equal to 20. So from starting 0 to 20, when we start running the timer, from starting 0 to 20, timer accumulator is not equal to this 21 value. So it's passing the current. That's why you can see this yellow color. Yellow color means passing the current. Okay. Now let's run it again. So start button to reset and run again because we have start button as reset also. So that's it. I guess now we have done too much about Ellen Bedley PLCs and a lot of content we have covered. Okay. Let's close this and quickly let's make this blinker in the hardware. Okay. And then let's jump to Siemens. Infinite blinker I'm going to make. Okay. Now I need to use actual addresses. Okay. I'm working with the hardware. So T4 colon 0. And now we have three features, as I said, 1.0, 1.001. If you want to run your timer for the number fraction, you can use other base time. And all these three base times are allowed because you are now working with the advanced version. Let's take preset as 2. Let's put a limit block and let it say when accumulator value is let's make it 0.01 and 200. 200 into 0.01 equals to 2 seconds. So when it is 1 to 100, pass the current. For comparison only, I take 200 because once again, I colon 0.0/0. Why I'm doing this 200? Because if I take this 1, I need to take this 2. And if I take this 2, what to write here? Because I need two values. If I write 1 to 2, if I write 0 to 1, if I write 0 to 1, then it will start initially without even starting the logic. Because if timer accumulator is 0 and it is 0, they both are equal, block satisfied and output is high. So I don't want to start initially without even starting this logic. So I put this 0.01 to 100. So when 1 to 100, output is high. Let's put not equal to block as discussed right now, and make it timer T4 colon 0 dot ACC when it is equals to 200. Let's put it equal to block. According to 21, I put it 210. Okay. T4 colon 0 dot ACC when become 200. Reset. I'm not adding counter for now. No need to communicate again because it was already communicated. Okay, I need to go here to run it. So it started working fine. 1 second on, 1 second off. Let's see. Right. If you want to make it blink fast, then you can do what? Let's make simple blinker. Now I'm not including these things. The previous concept, the basic concept, T4 colon 0 slash TT and T4 colon 1 slash DN to reset. We can do with the same method which we just did and also this method. Trying to include each and every method for you. Make it 1, sorry, 0.01. I want to make it fast, make it 100. Another timer. If I do it 0.01 and it is 100, that means 1 second on, 1 second off. It is already working. I want to reduce the value. Let's make 0.5 second on, 0.5 second off. So make it 50-50. Simple calculation. Multiply these two to get your timer delay in seconds. So 0.01 into 50 is 0.5 seconds. Now it's working fastly. It's not working. Okay, let me show you why it's not working. Let me share my screen. Because we made a mistake here, both the timers we take as 0. Okay, now let's run it. Now it's 0.5 second on, 0.5 second off. Doing it fastly. Okay, if let's reduce it more. I'm not sharing the screen, just changing the value to 10. You already know how to do it. And then I'll download to show you 10 and 10. 0.1 second on, 0.1 second off. Very fast process. And we have 0.001 also to make it more fast. I mean, we can do more fraction. So let's start it. So now you can look at it. Okay. One more thing I'll put as a part of fun. I just changed the output from 0 to 10. Okay, look at this now. Stop. Start. Stop. Done. Okay, now we'll shift to Siemens and won't take much time, but I need 5 minutes because now I need to shift my place from here to another PLC, that is this one, Siemens. Okay, so I'll be going there. Okay, so it will take 5 minutes to set up each and everything, and then I'll continue. Meanwhile, consider this as a break, and if you have any questions or doubts, continue with the live comments in chat. Okay, guys, if you have any questions or doubts related to Ellen Bedley, which we have now successfully completed, just let me know. We are going to start with the Siemens after this. If you have any questions, please write on the comment box. Actually, I told you this yesterday also that for analog sensors, we need scaling, right? Even I have included this in this session as well. But currently, the PLC which we are taking for the reference of today's session that don't have analog. And if I go to tell you about analog, I need to shift the whole process to another PLC, which would be quite difficult as we are about to end very soon after Siemens. So unfortunately, I can't give you the example right now with the analog one, right? But yeah, if further we go for that, I can show you that thing as well. But I can just simply tell you that we use scaling for analog inputs. Even yesterday when we were having a question and answer session, that time also I told this. Meanwhile, I'm completing the setup for the next Siemens PLC. If you have any questions, please ask frequently. Okay, let me first clear the last doubt, then I'll restart. So you have a question, how many timers we can use as an output as an input, right? Because you have said avoid repeating output in different run. So I said avoid repeating output in different run. But when you use the symbol of output, right? So if you use the symbol of input, you can use n number of times your output address. There is no problem because that time your output is not behaving as output. It is going to behave as an input, which is actually called the feedback part. I hope it is clear to you. Okay, so my setup is ready. Okay, let's start with this Siemens brand. Okay. Now, let me first give you the overview of this Siemens. Then we'll come to the hardware and all. Okay. So currently, I'm talking about Siemens, a German brand, right? And for this German brand, currently the PLC I have is this PLC, especially. Another PLC I also have, that is 1200, but I'm currently talking about S7 200, which I have this one because we are starting from the basics. So considering this one, and it has a CPU type as 222, right? And here we have around 8 inputs and 6 outputs. The total 14 DIOS. The complete name of this PLC is S7. S7 means step 7. Okay. S7 200 222 24-volt DC input and 14 IOS. The software which I'm going to use for this is step 7 microwave. Nowadays, we have a lot of advanced version of Siemens PLCs available, that is schematic and 1200, 1500. For those, we use TIA portal, right? This one is your S7 200, right? So here we have around, as I mentioned, 8 inputs. So let me take it close, the camera. Let me take it close. Yeah, now it would be fine. And also need to stop sharing the screen. Yes. See, we have around 8 inputs, okay, and 4 outputs. Let's try to understand. So this one is the first input, second input, third, fourth, fifth, sixth, seventh, and eighth. Okay, these all are NO. These three are NC. These are direct inputs. Okay, this NC is also direct input, but these two are emergency buttons. We have to use it this way. Push, it is holded. Now this, now rotate to open this. I'll show you again. This LED is creating the reflection. Let me hide it. Now push, hold it, and then rotate. Push, hold it, and rotate. Come back. Okay. So these three are NCs and NO. 8 inputs, right? Six outputs. I said 6 outputs. 1, 2, 3, 4, 5, and 6. Correct? Now let's come back to this. So I told you it won't take too much time. Why I told you this? That is the reason. See, P is equals to IR is same. Okay, the screen is not shared. Let me share. See, Y is equals to IR is same. Not Y. V is equals to IR is same. V is equals to IR is what? Ohm's law. Logic gates are same. If I tell you about AND gate, it is Y is equals to A dot B. OR gate, it is Y is equals to A plus B. When we shift from one PLC to other PLC, all the logics are same. V is equals to IR is going to work same for all the countries. Even it is China, Japan, Germany, India, USA, Africa, anywhere. If we discuss, the concepts are same. What changes? The language changes. Right? We know that we are joining this session from many different countries, and we all have our own different languages. We all have different techniques to understand the logics. For example, you know, when we discuss about the Allen Bradley, it is a USA brand, USA brand. Japan, Mitsubishi, Siemens, Germany, Delta, China. So we have different varieties of vendors from different countries. So what changes they have? In India, we used to say input as I, and output as O. But when we go to China, they use X as input and Y as output. Japan, they use X as input, Y as output. Germany, they use I as input and Q as output. That's why in Delta, when we talk about inputs, addressing has X and output addressing Y. Mitsubishi have same pattern. But when I tell you about USA, input is I, output is O. Same pattern as Indians. Then Germany, Germans follow input as I, output as Q. So that's what is the difference. And that we will understand within a minute, right? So let's come to this now. And what is the change is all about data files. The change is all about data files, right? So we have first data file as input and input address is I 0.0 to I 0.7 output. Q 0.0 to Q 0.7. I have already shared this software with you guys, but this software is not going to work without the hardware. You need a hardware for this. And if you want simulator, I'll share the link post session. Right now, it's not possible. Post session, I'll share the link for the simulation. Generally, it is quite difficult to cover each and everything like a Logix Pro simulator, then Micrologix 1000 and 1400. Now it's about to end. So if I use Siemens software, original one also, then the simulator one would be quite difficult. So just taking it as what original software, the main software with the hardware. Okay. For schematic, simulator, you can ping me. I'll share the link. Okay. Other than that, if you need TIA portal, as I mentioned, for advanced version of PLCs, the smart versions of Siemens PLCs, we need TIA portal. If you need help in that software, I can provide you that also. No issues. Okay. Next. So binary, which is memory here. It is not called binary here. It is M0.0 to M0.7. Right. Let's try to understand these three things for now, and let's start doing the coding. Firstly, the cable is connected to my PC, and this is PPI cable. This is PPI cable. I already mentioned yesterday, I guess, that we have two cables, PPI and MPI. PPI is point-to-point interface. MPI is multi-point interfacing. Right now, I'm using PPI for serial communication. Okay, and let me open the device manager to check the COM port of the PLC. So if we go to device manager, there we can see the COM port, which is currently not showing. Let me connect the cable. Yes, connect cable connected, updated is COM port number 1. Let's close it. Now, in the case of Ellen Bedley, there was two softwares. One was RS Links and other was RS Logics. RS Links was for communication and RS Logics was for programming. But in Siemens, Step 7 Micromin is for both communication as well as programming, right? So let's open it. I am searching Step 7 Microwin, run as admin. Now the runs are changed to network. There it was run, now it is network. We just need to understand the basic tools and icons of the software, and then we'll let's do it fastly, right? First, network, it is not rung now. This is a network 1 mean rung 1, network 2 mean rung 2. In Delta, it is row. I told this yesterday's session. NO, and here only we have NC, right? Coil, that is output. So if we have to connect one NO, connect it, one coil, connect this way. If you want to delete, select, delete, select, delete. Okay. Again, one NO and then one NC and then one coil, right? If you want to take a parallel, select this parallel, down, line up. So take line down, although the arrow is showing this way, but I have to connect something here. So select your cursor at this point, put a arrow is moved to here. Now, if we have to connect something here, let's put cursor here and place NONC whatever you want. After this, you want this to connect here. So place cursor here, line up, it's connected. How to delete? Simply select, 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 select and delete. And how to delete the parallels? Either select here, you can delete it. Either select here or select here, you can delete it. Got it? Now, let's make a small program. Address are I0.0 to I0.7. We have 8 inputs. Okay. So this one is I0.0, 0.1, 0.2, 3, 4, 5, 6, 7. Outputs Q0.0, 0.1, 0.2, 3, 4, 5. Okay. Now come back, sharing my screen again. So let's take first input as I0.0 emergency and Q0.0 as first output. How to download the program? For that, first we need to communicate. If you don't even communicate, this Siemens automatically communicate before downloading the program. So I'll show you both the ways. First, I'll download the program and I want it to automatically detect the communication. So here is the option to download. So it has compiled, no errors. Program is ready to download. Let's click it. The PLC is already in the running mode. That's why the LED is on. Some program is already running there. So let's keep it okay to make it in stop mode. You can see the PLC stopped. The program is being transferring here. Let's get back to the PLC in the run mode. Now run the PLC, run the software in online. So your PLC and software both are in the online mode now. Okay. So the first input is the NC button we can see. That is why I have not pushed it. The output is high. If I push it, the output becomes low. Working opposite. Okay. If I open, the output is again. Right. Now, if I want to make this as NO, simply what we have to do, let's make a symbol of NC and I0.0. Delete this, connect this, download again. Run and software on. So now it's working as a NO. When I push, output is on. When I release, output is right. Now, this was the method how to download and how to run. I told you once you understood the concept of Island Bedley, it will be very easy to understand Siemens as well. Whether you are working for 1200 TIA portal, anything you are working, it's very easy for you now. Now it is automatically detecting the communication, but in any case, if we have to communicate, we are facing errors while downloading for the communication. It's not communicating because of cable and something port numbers. And how to communicate? Simply go to communication. Okay. The first option. If everything goes smooth, go to communication. Simply double tap here and you'll be able to see it is communicating. Wait for it. Although it is already communicated, it has shown the driver name, address name, and at this which speed it's working. Speed mean baud rate. 9.6 kb per second is transfer rate of your program. So it has completed the communication, right? Successfully communicated. Sometimes you may need to set up the settings if you are facing the errors. So what are the settings? Go to set PG-PC interface. Now choose your cable. So as I told you, we are using PC PPI cable. This cable we are using, right? So select double tap or on this point, PC PPI cable. Let's close it for now. PC PPI cable. Let's double tap. Go to local connection and check if your port is same or not, which was in the device manager. So it was COM1. So select the COM1, say OK, and then double tap. It will start communicating, and once you start, you can see the driver. Although it is communicated, but still let it complete first. Don't cancel in between. Don't interrupt the process. This is the way to communicate, right? Then now we'll make a start stop logic. Then we'll jump to timers. Parallel we need now. So down arrow and one NO, one NC and one coil. Okay. Now I'll be using these inputs, this one and this one. So this is I0.2, I0.3. No, not 0.2, it's 3. 0.0, 0.1, 0.2, 0.3, 0.4. Okay. So let's use 0.3 and 0.4. I0.3, I0.4. And here Q0.0, Q0.3. Not using the same output. Let's use third. Let's download. Communication error because we changed few settings. Maybe something gone wrong. Let's do it again. Still error. I'll restart the software. Oh, sorry, I opened the wrong one. Step 7 microwin run as admin. Okay, now it's done. So again, let me create the start stop logic. This is good thing when we face errors during the live sessions or teachings. It helps to participants to understand like how to clear these kind of errors. So I 0.3 as a NO and I 0.4 as a NC and then Q 0.0 as a not 0.0. We have decided to take third and here also Q 0.3. So let's download this. We have additional feature in this Siemens PLC. If you want to stop the PLC, Alan Bedley was having the same option. If you don't want your program to run, I mean, suppose you downloaded the program. Just wait for a minute. First, let's complete it. Otherwise, two concepts will mix up. Okay, we made a mistake. It should be NO Q0.3. Download error. We have not connected this. Yeah, now it's done. Okay, so start stop is ready. On. Okay, off. On, off, on, off. I guess I don't need to stop sharing my screen because on the camera screen it is visible, clearly visible. The output is on, right? Done. Yeah. So now what I said in Ellen Bedley, you were having the option. Suppose you downloaded this, remove the cable, still the program continues on, off, whatever you want. I mean, program will still run if you even remove the cable, even if you shut down your PC, because program is already there, right? But if you want program not to run, you can go to this option and say stop. So if you make your PLC in stop mode, you cannot run this output now. See, now it's not working. Why? Because you have stopped running your program from the software. So now let's say if you turn off the PC, in the case of Alan Bedley, this option was there when we make it remote program mode. So if you make it remote program mode, PLC program is not going to work. Although it is already loaded, but it's not work. It is not working. But when we talk about Siemens, suppose you stopped like I did right now and you turned off the PC. But here in the PLC, you have the option. You open it, simply switch it to run mode. Okay, I'm not doing anything from PC, right? I did it from here. Now, if I run again, it's working. Even you have option. Let me stop sharing my screen, the full view. Even if you have the option to stop your program from here only. Currently, it's running, but if you make it to stop mode, see, it's not running. Look at this color. The orange color LED is on. It is in the stop mode. But if I make it a run mode, it will go to green one. I hope you can see the colors. Now it is green, is in the run mode. Running. Now I made it stop mode, orange color. And if I run, it's not running. Keeping again green, run mode, working fine. Okay. Now come back to screen, and again let's do something else. So now we are going for the next one, that is timers, as I said. Okay. I'm just changing it to memory now, binary. Okay. To make timers. M0.0. Now we need to understand a bit of theory. Okay. So let's come to this screen, clear it and clear this. So timers, basically here you have three timers, T on, T off, and TONR. T on is on time delay, off time delay, retentive timer, same like Helen Bedley. Okay. Then here you have 16-bit of timers, same like Helen Bedley. Okay. 16-bit mean 2 to the power 16, max value is minus 3276 8 to 32767. After this, you have T0 to T255, 256 timers, 256 timers. Base time 1 millisecond, 10 millisecond, and 100 millisecond. Three base times. There you were having 1.001 and 0.0001. Okay. Other than that, what else you have? Here you have enable bit, TT bit, done bit. No, you have only done bit. And the address of done bit is the same as timer's address. There you have T4 colon 0 to T4 colon 39 timers. Done bit is T4 colon 0 slash DN. Accumulator is T4 colon 0 dot ACC. But here it is timer is T0 to T255. Done bit is also T0 to T55. And when we talk about the usage, preset and accumulator, preset is not available to use. Accumulator is available only. And the address is T0 to T255. 256 accumulator address, same as the timer address. And the last but not the least, reset is available, but not with the RES. It is available with R only. Got it? So this was the theory part. One more thing need to add it here. Here we have 1 millisecond timers, 10 millisecond timer, 100 millisecond timer. What is the meaning by this? There also you had three base times, right? But there the base times were not fixed for timers. Mean what? If you want to take T4 colon 0 with one base time or if you want to take T4 colon 39 with one base time, it was possible. But here Siemens have fixed the address according to their base time. What I'm trying to tell you, let's see that in the software. So first I'm taking one memory bit, M0.0. How to put timers? Go here, simply write T on, and then what I did, simply go there and write T-O-N, and T on is here. Okay. Now, when you place your cursor, it will show you the address. You have only two timers of 1 millisecond, T32 and T96. Note it down somewhere. You have only two timers of base 1 millisecond, that is T32 and T96. Then 10 milliseconds, you have T33 to 36, four timers, and then T97 to 200, again four timers. Total eight timers of 10 milliseconds. And then you have T37 to T63 and T101 to T255. So these timers are for T on and T off, and with these base times. Now, if I take TONR, another timer, which we didn't cover in Ellen Bedley as well. If you take TONR, then again you have fixed number of timers available. T0 and T64 is available for 1 millisecond. Then for 10 millisecond, T1 to T4 and T65 to T68 is available. And for 100 millisecond, T5 to T31 and T69 to T95 is available. Got it? So now let's take one timer, that is T on, and I am taking, see, as you define the address, as we can see, 1 millisecond is T32 and T96, right? So if I write T32 here, just after entering, look at this base time, it becomes 1 millisecond automatically because it know T32 is 1 millisecond time. So if it is 1 millisecond and if you want to run it for a second, again, same logic. Preset need to be multiplied with the base time to get the delay time. To get the delay time. Just give me a second. Battery is low. I need to turn on the charger. Yes. So what I said, now the, oh, sorry, which switch I on? Yeah, now it's charging. So what I said, here we have 1 millisecond as a base time, right? So this base time is to be multiplied with the preset value to get your delay time. For example, if you want to run your timer for, let's say, 1 second, okay? If you want to run a timer for 1 second, so you need to multiply this preset with base time. So currently the base time is 1 millisecond. So how much should be preset? It should be 1000, so that you can get 1000 millisecond, and 1000 millisecond is equal to 1 second. I hope you get it, right? Now let's take it as 5000. 1000 mean 1 second, so 5000 mean 5 seconds. And a done bit, that is T32, and the output, that is Q0.0. Ready? And let's download. So now if we run, we'll get the output for output after 5 seconds because it is a done bit, right? So if I run it, I'm not getting any output for now. Timer is giving the delay, and after 5 seconds, we'll get the output turn on. One more difference we have. Can you see the timer's preset is not stopping here? I mean, accumulator is not stopping here. When we did when we did Allen Bedley, once it achieved the preset value, once the accumulator achieved the preset value, it was stopping. But here it do not stop. It will go up to the max value, which is about to come 32767. Stop now. But How we came to know that the task is completed? Done bit. Just after 5 seconds, the done bit was high, right? Now, further, if you have to take this output, when you start the timer, that means you want TT bit. So how we can do it? As we know, we need to take memory and NC of done bit. The same concept we built in LNBD. That's why I told you that concept that time. Now it is quite easy to understand. So almost things are same, right? What is changing? The features and how to handle. I mean, handle mean icons and all, right? Start, not giving the output. Okay. Stop and start. Can you see the output is on? After 5 seconds, it will go up. Done. Now let's put a counter. So we have counters here. So we have total three counters here. CTU, CTT, and CTUD. Counter up, counter down, counter up, down. So it has one additional timer of up down. Okay, it can do plus and minus at the same time. It can plus, it can minus. Okay, it will count 1, 2, 3, 4, 5. It will count 5, 4, 3, 2, 1. It will count 1, 2, 3. And at the same time, if you push the down input, it will come back 3, 2, 1. Okay, so addresses C02, C255, 16-bit. I'll not explain the 16-bit. I hope it is clear already. So maximum 32767. Then after this, only done bit, and the address is C02, C2 double five, and according to the usage you can use only accumulator. Address is C02 C2 double five again, and for reset R option is there, and what to write? C02 C double five to reset. Okay, now one more thing here. Reset for the counter is not mandatory to take separately, because counter block itself contains the reset. How? Let's do it. So let me create a new file, and let's take one input and one counter. Now we need to set CTU, C0, counter, preset values say 5, input address is say I0.3. Okay, see the reset option is already here. If you don't want to reset, okay, sometime it may happen you don't want to reset. If you skip this, if you don't connect any input here and you download, it will give you error. One error message is there on the bottom, right? Errors were detected while compiling the block. Please cancel and correct all errors located in the output window, right? So this one is your output window where it is showing you what? 0 bytes and one error. If you maximize this output window, you will get the exact error. But currently I'm telling you what is the error. So you need to connect the input anyhow. Now the point is you don't want to reset. Still you need to take the input. If you want to reset, you can take I0.4. If you press it, it will reset. If you don't press it, it's not getting reset. Okay. So the first option, if you don't want to reset, don't press it. But you are wasting one input here. We have to avoid that thing as well. So take memory. Input saved, will not reset it. That's it. Okay. So let's download. Now there is no error, no warnings. Okay, I'll not download now. Let's take done bit also. One done bit, C0, and one output Q0, Q0.0. Let's download. Let's run. Let's go to play mode. And now I need to count 5 times because we have mentioned preset as 5, then done bit became high, and then the output is. But here, unfortunately, the memory is high. In the last program, the memory was high, so it is high. I can stop it from the software, make it off, forcefully off. This is called forced off. Okay. Now, if I go here, make it 1, 2, see the counter value here. This is accumulator, 3, 4, and 5. And done bit is high, and your output is high. If you want to reset, apply the forces. It is reset. Now, keep it off again. Okay, so counters are also done. Now, last but not the least, let's create a new file and directly limit block is not available here. Okay, we have less than equals to and greater than equals to and not equals to blocks here. But the blocks are here basically divided. There we were having the blocks only for integers up to 16-bit. But here the blocks are divided according to, let me open this. Now here the blocks are divided according to what? What happened? Nothing working. Wait, I guess something is not working. The system is turned on almost from 12 hours. Just after your first live session, which was running in this, I mean, streaming was running in this only. And just after that, I started recording this session, which I'm doing right now. So maybe system is bulky. Yeah. Yeah, now it's working. It's working. Okay. So I guess I was in the concept of, yeah, limit blocks and all. So let me open this. Let's come to this one. And so there you were having the blocks for only integers, right? And integers mean 16-bit. But here the blocks are divided according to byte, integer, double integer, real, and string. Byte mean 2 to the power 8 max, 2 to the power 16, 2 to the power 32 max, real numbers, like decimal numbers basically, or string A, B, C, D if we have to compare. Then we have different registers for each. Register mean integer files, N7 colon 02, N7 colon 100. Here we have VB02, VB100. Here we have VW0 to VW100. And there we have VD0 to VD100. This way we have register, right? This is a lengthy topic, but let's try to complete with the byte block, okay? But if you have to use the timers, because timers are 16-bit, so you cannot use these blocks to compare the timers because this block has the maximum range of 8-bit only. So in that case, you need to use integer block, right? Come back to the point. So I'll be using one block, let's say less than equals to byte and one output Q0.0. First, I'm trying to show you how this block works. So if I say 2, if I say 3, so 2 is less, if 2 is less than equals to 3, this works as NC, give you output high. Let's check it. Download, run, and online. So the output is high because 2 is less than 3. Look at this. Okay. Now, if I change the value, I keep it 1. So this time 2 is not less than 1. So output is not going to be. So the output is not high now. Correct. Now, the next thing is what? If suppose I enter the value greater than 2 to the power 32. 2 to the power 32 is what? 2 to the power, I mean, sorry, 2 to the power 8 because byte block has the range of 2 to the power 8. So if I mention the value greater than 2 to the power 8, it will definitely give us the error. How? Let's enter 2 to the power 8 is equals to 256. And 256 is what? 0 to 255. So if I enter greater than 255, let's say 256, can you see the red line there? That is the error. Right now it is indicating, but still you want to try, click download, it's giving you one error, right? So now what we need to do, we can maximum 255. And if you have to compare 256, then you need to shift to integer block. Okay, I'll come to that again, but first let's complete it with the registers. If you have to take registers, let's take VB0 and VB1. I already mentioned N7 colon 0 to 100 in Allen Bedley. Here we have registers according to the blocks. For the byte, we have VB0 to VB100. V mean variable, B mean byte, variable byte registers. So how we can assign the value in the run mode only? Simply download your program, right click, and now write 34. And in VB1, I'm writing it as 67. So 34 is less than 67. The output is high. See it on the back side of me. The LED is on, and even in the software also it is showing. If I mention it 32, if I mention it 32, 34 is not less than 32. The output is off, right? Now, if I want to take integer block, let's go to, wait, not integer block directly. If I take T0, suppose I'm mentioning timer's accumulator. Again, it is giving error. Why? Because timer is 16-bit and the block which you are taking is byte block, 8-bit. So you need to shift yourself to integer block, less than equals to I. Now you can take more than 255. 256 is allowed. At max, what is the value? 32767. If you take 32768, it is also giving error. Then you have to take 32-bit block because it has the range up to 16-bit. But this block works fine with your timers and counters because we have timers and counters of 16-bit in this PLC, right? Not all Siemens PLC I'm talking about, this PLC, right? Other PLC may have different scenario that depends upon PLC to PLC of Siemens versions. So for that, you need to simply cross check the manual. If you go to ChatGPT or Google and simply write Siemens, this model has how many number of timers and what is the maximum bit they hold, it will clearly tell you, right? So accordingly, you can decide. For now, if I'm comparing 32767 and here I'm comparing 3 to same 767, it will give the output high because 32767 is not less than, but it is equal to, because the block is less than or equal. So it works for both, either equal or less. So currently it is equal. So the LED goes, look at the back side. But if I want to compare the timers, first of all, I need to take the timer. So I guess we have done too many things here, right? If you want to put one more, so if you want to change in the run mode, take VW0 and take VW2. Why VW2? When you take the registers for integer block, when you take the registers for integer block, they are VW0 to VW100. But when we talk about VW0, if you store any value in VW0, you have to skip VW1 because it store 8-bit and by default it use next register to store the 8-bit. Currently we are talking about the 16-bit block. So if you use VW0, you need to skip VW1 because by default it stores the value 8-bit in VW0 and 8-bit in VW1. Same randomly, if you take VW2, randomly mean you taking 20. So if you take VW20, you need to skip VW21 because it will store 8-bit here, 8-bit. Now, in the same way, if I tell you about this VD0 to VD100 for 32-bit, if you use VD0, skip VD1, VD2, and VD3 because it's a 32-bit block. So 8 plus 8 plus 8 plus 8 is going to be 32-bit, right? So in that case, you need to skip all these three, VD1, VD2, VD3, you can't use. If you use, it will start uh, getting the garbage values. Let me show you. If we see VW0 and VW1 here, right? And let's start downloading. It won't say anything right now. When you assign the data, then it will tell you. So for example, if assign the value in VW0, that is 3345, see automatically it assigns some value in VW1 as well. Earlier it was 0, but now it assigned automatically. It's a garbage value, right? So it's not allowed to use VW1. You need to skip it. Use any of the register other than 1, 2, 3, 4, up to 100, any. Okay. So I used VW1. Now it will, VW2 I used. So it will work absolutely fine now. Let's check it. So it is VW0. I'm writing more than 2 for 256, more than 8-bit, according to 16-bit block. So it's 356 I'm writing here. Nothing goes into VW2. Now I'm writing in VW2 456. So yes, 356 is less than 456. The output is high. If I change the value to from 456 to let's say 300, then the output goes low, right? Now, how to use these blocks with timers and counters, that would be the final program for now. So once we need to take one start stop logic. Let's take another output, I0 dot 3. All the examples which we did with Bradley, you can do here also, Q0 dot 0, and then not Q, let's say M0 dot 0 and M0 dot 0 and M0 dot 0. Sometimes student may start doing the program here. So don't do this way. Okay. Network one will hold only one ladder. So this one is wrong. You have to shift to next one. Let's take one timer T on. And this is suppose T32. I'm running it for 2000 min 2 seconds and 20,000 min 20 seconds. Okay. And then I'm coming to take 2 blocks because now I want what? I want 5 second each output and continuous 4 outputs. Or let's not make it too lengthy. 10 second, 5 seconds, 2 outputs only, Q0 dot 0 and Q0 dot 1. So I need to take a limit block, but limit block is not here. So we can make it how? If I put greater than equals to integer, where it is, here it is. And then I put less than equals to integer. So what I'm saying, look at this. If your T32 is greater than 1 and T32 is less than 5,000, less than equals to 5,000, the first output should be high, which mean what? That for first 5 seconds, I'm turning this output on, right? So if we connect these two blocks in series mean they both should be satisfied the same time to pass the current. So if it is greater than 1 and if the accumulator is less than 5,000, so till your accumulator is till from 1 till 5,000, these two blocks will pass the current and output goes high. Next, I want the output to turn on, not this block, again same scenario, less than equals to and greater than equals to. So I'm putting T32 again, less than 5,001 because it was still 5,000. Now T32 less than 10,000. Next output should be high, Q0 dot 1. And then let's put a last one, the reset one. So T32's done bit is going to reset. Reset is R here, I told you. And R asks you two different address. Here you can write the timer address. Here you can write simply one. If you use one reset in your program, write one. If you use two, after this is one. Next reset should be two. Next should be three. Okay, this way you have to change. Now let's download. Run, and let's go online. So now, according to this, two outputs are there. They should work 5 seconds each. First output is working for now. Now, second output is working. Shifted the output again. First output. You can look at this. This way, you can make too many programs, which whichever you want. So I have completed the part which we did in Ellen bit, and I guess too many things we have covered. Okay. Uh, After this, there are too many other things also, but almost I have told you about the basics of Ellen Bedley and Siemens. Further, as I said, we'll plan for long sessions as well. And my expertise is not only with the PLCs, not just with the industrial automation. Industrial automation mean PLCs, SCADA, HMI drives and all. But other than that, I hold my experience in IoT as well as electric vehicles, design and simulation with MATLAB, embedded systems with 8051, AVR, Arduino, Raspberry Pi, and then STM32 as well. And after this, if you want something like ROS, robot operating system, I do have experience there also. MATLAB in mechanical engineering, MATLAB in electronics engineering, MATLAB in electrical engineering, MATLAB in computer science engineering. So I do have a vast experience there as also, and even robotics is also one of my favorite field. So I'll try to keep those kind of sessions also in future. If you would be interested, ping me on LinkedIn. According to the feedback, I'll go further. And about the certification now, I'm not ending this session, so don't start leaving because after this we may have a uh, live session on Zoom that depends upon your requirement. It depends upon your doubts. Okay. Also, I'm going to show you one more PLC, then I will end the session. But before I show you that PLC, yes, so before I show you that PLC, let's discuss about if you have any questions or doubts, and then we'll go further with uh, the PLC which I'm about to show you for the Siemens, and then we'll end it up nicely. Just let me know in the comment box if you have any questions or doubts. If not, we'll soon end it up. And yes, for certification, I have even just mentioned in this live chat currently that uh, although I have said this thing earlier also, and if you are asking for if you're asking for next sessions as well, as per the feedback of this session, I'll go further. And for certification, we'll be sharing the link soon, so that if you want, if you are interested, you can get that, and it will cost you amount in INR 100 plus taxes, Indian currency 100 plus taxes. So I guess it's not too much. It's around $1 or one point something dollar in USD, right? So as per your country and transactions fees and all, you'll get the amount, and accordingly you'll get the certificate. Once you pay for the certificate, you will soon get the information by WhatsApp message or by email or by maybe by LinkedIn that your certificate is ready and you can download it. So you can download the certificate from our web portal, which would be globally accepted, which even you can post on LinkedIn as well, right? Ankit, I am from Dehradun, Uttarakhand. Yes, I'm waiting for the queries. If you have, please continue. I guess I have given too much, and now you guys may be exhausted. Even It's being continuously 4 hours for me sitting over here, and even just before we start the session, I need to prepare the set things. I need to prepare the setup and also additionally 1.5 hours for me. So, and even after completing the session, you may just close the window and that's it. But in my case, it would be very hectic to settle down the things. I understand you are exhausted, but even if you have any questions, please ask. In rand, how much? Need to calculate the currency calculator. Let me tell you, INR to rand. Just give me a moment. I'll tell you. It's 0.18 South African rand. It's point, no, sorry, not 0.18. It's 17.68 South African rand. Timer is only on, off, and retentive. There is no up and down. Okay. In the case of counters, we have up and down. So if you use only on timer, you can do everything with the on timer as well. But wherever if you want like to pause the process, then retentive timer is required. You can skip T off, you can skip counter down because timer on is also going to give you the delay, and you can use that in place of T off. But in the place of RTOs, or that means retentive timer, you can't use them. Then secondly, about counters, you have to count the process like 1, 2, 3, 4, 5 or 5, 4, 3, 2, 1. That's your choice. So counter up is easy to understand, easy to execute. So I recommend to use CTUs only, counter ups only. Yeah, sure. I'll prepare for more sessions. No worries. I already told you about my experience. I hold experience in too many other fields as well. So definitely after the feedback, as I mentioned in the chat box as well, to one of the participant who was asking for more sessions of PLC, I said I'm raising the funds for social cause. So if I'm successful getting the funds, definitely I'll go for free. I'm doing this since 13 years, and a lot of my students are asking me to post all the content to YouTube, but I never posted any content to YouTube, just because sometimes when we when we start posting the content for free of cost, we avoid the things like if I'll tell you about this session also, we are watching it live, and those who haven't participated, if I share the recording, then also they'll skip it because everyone skip the free content. That's why I've never posted it. But now I got opportunity from one NGO and they asked for the funds, and I got idea to raise the funds this way. That's why I'm doing it. Uh, for Nepal, what would be the payment method? See, I'll share 2 or 3 or 4 links, okay, according to different countries for PayPal and Razorpay and Instamozo, different payment gateway links I'll be sharing, so that would be suitable for you. If you have anything important from your side, you can also text me on the live chat so that I can go accordingly. That's why I was asking from you guys to test the payment link which I already created. But I got one response from one candidate from Pakistan that PayPal is not available there. So no worries. I know that this session is a global session and we have too many countries connected here. So we'll generate the links accordingly and provide you. No worries. We'll give a common message with different links of different countries. Let's see how it works. For Nigeria, I don't have any solution because whatever I search for Nigeria, it's simply telling that international payments are restricted. Okay. But yes, when I discussed with one or two clients of mine, they asked me to create the local account in Nigeria, or otherwise PayPal is working there. So PayPal already have. I have shared the link with one of the candidate. He's testing it. Once it is tested, I'll share it. At Brain, if you are from Saudi, just wait for some time. Okay, we will be sending the payment links, and once you receive the payment links, you have to simply pay and complete the formalities. And once you complete the formalities, you will get the certificate. You will get the message to download from our web portal. It's my pleasure, Rajeshwari. Yes, that is my motive, and once it is completed, definitely I'll come back with more sessions on PLC, other industrial automation, and other technologies as well. Okay, I individually can't say about any country right now. Okay. So if you have any payment restrictions in your country, please text me, please DM me on LinkedIn so that I can go accordingly. Right. Whatever I have observed till now, I had discussions with Razorpay Payment Gateway and PayPal Payment Gateway. They told me that all the countries they have in their uh, expertise, and I mean they have tie up with almost all the countries. So PayPal is working almost everywhere. But I just got a feedback from one of the candidate from Pakistan. It's not working there. So for that, we have another solutions as well. No worries. I have already shared the simulator for Siemens. Can you see the live chat, please? I have already shared the link for the download. When you ask, at the same time I shared the link. TIA portal basically itself hold the simulator. So I have shared the link for TIA portal. You can use that to simulate 1200 and 1500 with virtual hardware and even with the hardware. Okay, no new messages now, right? No new chats. So I'll just uh, turn off the camera for around 2 to 10 seconds. I'll go to another place and show you another and last PLC. I'll not discuss anything about that, but I'll show you the industry kind of atmosphere of that PLC. And you see it, it's from Siemens, and then we'll end it up. Okay, PayPal does not work in Nepal, no worries. We'll have another solution. I guess Razorpay InstaMoza would be working there. So this is another model which I was telling you about Siemens model and have an industry kind of scenario, right? So if we go to industry, we may see the panels, something like that, and it is also from Siemens, right? It has too many other contents as well, like too many other things as well. Let me take camera closer. Here we have interface of voltmeter, ampere meter, and then we have AC as well. Then we have relay module as well. Then we have PLC module there. We have pump. We have solenoid valve. Too many things. And this model of Siemens is basically work with 220 volt of AC as well as 24 volt of DC. But the output is always 24 volt DC because it does not require any does not require any SMPS to connect with it. And if we discuss about the input modules, we have sensors, toggles, limit switches, too many things we have added in this industry kind of scenario, right? So this one was the last thing which was need to be discussed, and now we can, I guess, close this session if you don't have any questions or any doubts. Yes, sure. If I achieve my motive, definitely I'll arrange few more sessions. Okay, guys. So thank you so much. Thank you so much for being here. Thanks for your participation. Soon we'll do something else if I achieve my motive. And have a great time. Do practice with PLC. It has a very bright future. So at last, I'll say, I'll not say too much. Simply all the best to everyone. for their future endeavors, for their careers. Goodbye. Take care.